Yeah, hi everyone. So now in this video we need to study about statistical parameter of random variable. So these are the parameters. Okay. First one is like they can ask you what is the mean of random variable x? What is the mean square value of random variable x? What is the variance of random variable x? What is the standard deviation of random variable x? So all these are defined with respect to one dimensional random variable. Okay, one dimensional random variable, and these are defined with respect to two dimensional random variable. That what is the correlation between random variable x and y? What is the covariance of random variable x and y? What is the correlation coefficient of random variable x and y? So they are defined with respect to two dimension, they are defined with respect to one dimension. And here if joint word is not coming, what does that mean? If I say nth order movement about origin of random variable x and nth order joint movement about origin of random variable x and y. So they are defined for both 1D and 2D. Okay, so we will understand the meaning of each of them one by one. They are very simple. This lecture will be very simple. Okay, very straightforward. So we will understand the meaning of each of them. You will understand every single thing. Okay, don't worry about that. So nth order movement about origin for random variable x and nth order joint movement about origin for random variable x and y. So if the joint word is coming, that means it will be defined for 2D. If joint word is not coming, that means it will be defined for 1D. So we will study about all of them one by one, but first we need to study about one operator. So this operator is known as expectation operator. So what could be given in the question? It will be mentioned that x is a random variable. You find the expectation of random variable x. Find the expectation of random variable x. We will study all of them, but before that we need to study about expectation operator. So what will be mentioned? A random variable x represents all these things. You need to find the expected number of chocolates the child will receive. So what you need to find? You need to find the expectation of random variable x. So how do you find the expectation of random variable x if PMF is given? So what is this? This is PMF only, no? What is the meaning of PMF? Random variable x is taking value 1, random variable x is taking value 2, random variable x is taking value 3. So discrete values it is taking. So how would you find the expectation of x if PMF is given? If PMF is given. So what you will do? What value these random variable can take? So this random variable can take, what you will do is that you will tell that the random variable can take values 1, 2 and 3. And what all are the probabilities associated to these random variables? So with respect to 1 it is 0.2, with respect to 2 it is 0.5, and with respect to 3 it is 0.3. Now what you will do is that you will take the value and multiply with its probability, plus you will take the value, multiply it with its probability, then you will take the value and multiply it with its probability. There you go. So what you will be getting? 0.2, 1, 0.2 plus 1 plus 0.9. So you are getting 2.1. So this is the expectation of random variable x. What does that mean? That means that if the child is spinning the wheel, so basically what was the scenario here? There was a wheel, basically there was 3 sections, right? How will I make 3 sections? This is how I can make 3 sections. So here 2 chocolates you can get, and here 3 chocolates you can get, and here 1 chocolate you can get. So this guy will spin the wheel. So getting chocolate 2 probability is 0.5, getting chocolate 1 probability is 0.2, and getting chocolate 3 the probability is 0.3. So if this guy is spinning the wheel, there is chances that he will end up getting 2.1 chocolate. Actually he can never get 2.1 chocolate, no. He can get 2 chocolates or 1 chocolate or 3 chocolate. But it is said that if this experiment is done 1000 times, then it might happen that in the end of the 1000 time he will be having roughly around 2100 chocolates, because expectation came out to be 2.1. that means if the wheel is spinning for one time, then expected value of chocolate the child can receive would be 2.1. so if you are doing the experiment for the 1000 time, then the chocolate you will receive could be 2100. This is the expected value. So nearly around this much chocolate it will get. Nearly around 2100 chocolate the child will be getting. But as of now our target is to focus on the formula. what does the formula say? That whatever the value it can take, whatever the value a random variable can take, multiply it with its probability and keep on adding up. So it can take value 1, probability is 0.2. It can take value 2, probability is 0.5. It can take value 3, probability is 0.3. So answer is 2.1. So what will be the formula? Expectation of random variable x is given by, although formula is not important, what you will do, you will take all the values of random variable x and also you will take its probability and you will keep on adding up all of them. So I equals to 1, I equals to 2, I equals to 3, I equals to 4, everything will come into action. So here what we actually did, expectation of x was, what we did, first value we took, x can take value x1, that means it can take value 1. Then we multiplied it with its probability. Then we took the value 2, then we multiply it with its probability. Then we took the value 3, then we multiply it with its probability. So this is what we done. 1 into 0.2, 2 into 0.5, 3 into 0.3. Answer is 2.1. Well and good, very simple. Now what if PDF is given? So here if PDF is given, then expectation of x will be given by, what you need to do? You will integrate for all the limit. You will integrate for all the limit. Now you will see whatever that is written here. What is written here? X is written here. So I will write down small x. Here x is written, I will write down small x. Okay. Now I will write down the PDF of small x. X into PDF of small x. So whatever the function is written here, just write it down in the smaller manner here. Whatever the function, here capital X was written, just write it down in small x. Let's just say in the bracket, if x square was written, what I would have done? Whatever the function that is written here, write it down in smaller function. Now you let me know, this is a function of x. So what is the PDF of random variable x? That is fx of x dot dx. So this would be your expectation of x square. Now you are finding expectation of x. So expectation of x square would be this. Expectation of x is this. Are you able to understand this point? So what this E is doing? What this E is doing? Whatever that is there inside, it will make it smaller, and this is a function of x. This is a function of x. So let's write it down as g. So this is a function of x, right? Since this is a function of x, that means here the PDF of x will come. If this is the function of x, so here PDF of x will come. If this was a function of y, so PDF of y will come. If this was a function of z, PDF of z would come. Is that clear to you? So we will see all these examples. So this is our expectation. What you need to find? You need to find the expected value of x. Expected value of x. What it will do? You need to integrate for the whole limit. Then what you need to do? Capital X, small x. Fx of x. Since this is a function of x, so here I will put the PDF of x only. Dot dx. Now x is actually going from 0 to 1. You are integrating with respect to x, which is going from 0 to 1. So here you have put the limit from minus infinity to infinity, which you will change from 0 to 1. Small x as it is. Now what is your fx of x? That is 2x dot dx. So what will be the answer? 2x cube by 3 from 0 to 1. So answer is 2 by 3. This is the answer. Okay. So 2 by 3 is the answer. Very simple thing. Did you understand? Let's write down more things here. What if they were asking you expectation of x square plus 3? What you would have done? What did I tell you? Whatever that is written here, capital X will be replaced with small x. Capital X will be replaced with small x. Now this is a function of x. So what you will put here? PDF of x. This is a function of x. That's why I am putting the PDF of x here. If this was a function of y, I would put the PDF of y here. If this was a function of z, I will put the PDF of z here. Is that clear to you? Dot dx. Now I can solve it. Okay. So a random variable y is defined as y equals to ax plus b. A and b are constant. X is a random variable whose PDF is fx of x. You need to find the expectation of y. What I need to find? I need to find the expectation of y. So what I will do? Minus infinity to infinity. Here what is written? Capital Y, so small y. Now this is a function of y. So which PDF I would require? PDF of y I will require. But do you know the PDF of y here? No. I only know the PDF of x. I don't know the PDF of y. I only know the PDF of x. So what do I do now? So what I will do, expectation of y. You know that y can be replaced with ax plus b. Ax plus b. Now what this expectation operator do? It will make the integration. Whatever that is inside, capital X will be replaced with small x. Now this is a function of x. So PDF of x will come. There you go. Is that clear to you? I tried doing by this particular, really sorry guys, here you will integrate with respect to y only, no? Everything is of y, so you will integrate with respect to y only. But you got to know that you are not having the PDF of y. So what you would do, you would find the expectation of ax plus b. You would find the expectation of y, which is expectation of ax plus b. Right? Now I know that I have the PDF of a random variable x. So what I will do, whatever that is inside, capital X will be replaced with small x. Now this is a function of x, so I need to put the PDF of x only, PDF of random variable x. So PDF of random variable x is fx of x dot dx. So now I can solve this. How will you solve this? Minus infinity to infinity ax dot fx dx plus minus infinity to infinity b fx dot dx. Say yes or no. So here you can take a as common. Now what will be this? What I have done, I have taken a as common. Basically I am taking a outside because a is a constant, no? A is a constant, a and b are constant. So a I am taking outside. So what do you think, what is this? Expectation of x only, right? And if I take b outside, what do you think, what will be the answer of this particular thing? Minus infinity to infinity x fx dot dx, what that would be? 1, right? So what will be the answer? B. So what you got to know here, expectation of ax plus b is coming out to be a into, is coming out to be expectation of ax plus expectation of b. So this is coming out to be, a is a constant which can come outward, expectation of x, plus b is also a constant, so expectation of any constant value will be that constant value only. So what do you see here? This is the thing that you can see. This is the conclusion that we have made. So what did you get to know here? That expectation always look for randomness. You can see that eventually the expectation operator is put only on the randomness. Which is the randomness here? In ax plus b, where is the randomness? Randomness only random variable x is having. So expectation operator will always look for the random variable. X is a random variable, so eventually the expectation operator is working only on the random variable only. Are you able to understand this point? So constant, either it will be taken out or expectation of constant will be the same constant only. Is that clear to you? We will see more example, we will see everything, but as of now we are just getting started and we have seen a very important point. What is the point that we have seen? This was the very important point, that here I was not able to calculate the expectation of y, but I know that y could be replaced as ax plus b. So if I put ax plus b here, then I would know that this is a function of x. So now I need to put the PDF of random variable x only. So I put the PDF of random variable x, I got this answer. Okay. So now let x, y, gx, x1, x2, all these are random variable, a, b, c, alpha are constant. So you let me know what will be the expectation of ax plus by. So what it will do? Expectation of, in between there is a plus sign. So expectation of ax plus expectation of by. Right? Here also it was doing the same thing, plus sign was there. So expectation of ax plus expectation of b. So expectation of ax plus expectation of by. Now this is the random, right? And y is also random. A is a constant, b is a constant. So a can be taken out. So a into expectation of x plus b into expectation of y. Say yes or no. What will be expectation of c? Expectation of constant. What that would be? Constant only. Because c is a constant, no? So expectation of constant will be constant only. What do you think? How will you break it? So here as well, randomness is there in x1, x2, x3, xn. So what you will do? A into expectation of x1 because in the plus it can be broken. With respect to plus, the expectation operator can be broken. So A expectation of x1 plus B expectation of x2 plus C expectation of x3. This kind of answer we will be getting, because B is a constant, so A is a constant, it can come out, B is a constant, it can come out, C is a constant, it can come out. So very simple thing, very straightforward, nothing difficult is there, and so on. Here you will see alpha expectation of x. What will be expectation of gx? So what you will do? Whatever that is inside, what is inside? Small gx, right? But this capital X should be replaced with small x. Now this is a function of x. Since this is a function of x, that means you will put the PDF of random variable x dot dx. There you go. So expectation of gx would be given as, here this capital X will be replaced with small x. Since this is a function of x, so you will put the PDF of random variable capital X only, right? And if PMF is given, then similar thing, g of xi, probability of random variable taking value x equals to xi, and you will do all the addition. Just integration is replaced with the summation, nothing else, right? Although it will be used only, this will not be used. Anywhere it will not be used. Wherever it is used, we can solve the problems. No need to worry about that. Now you let me know this particular thing. If x is greater than 0, then will this be greater than 0 as well? Because this is already greater than 0. Because you know that this will always be positive. And you are already saying that this is also positive. So positive into positive, and then you calculate the area, that would be positive only. So yes, expectation of x will also be greater than 0. So if your x is greater than 0, that means expectation of x will also be greater than 0, right? What about this? Can you solve this one? Surely you can solve this one. What you will do? Inside, let's try solving it. What do you get? A square plus b square plus 2ab. I just solved this square function. So a square into x square plus b square plus 2ax into b. So plus 2abx. Now what I can do? A square is a constant. So expectation of x square plus expectation of b square. What that would be? B square only plus b square plus 2ab is a constant. Expectation of x. This is the answer. Okay. What is the answer? A square expectation of x square plus 2ab expectation of x plus expectation of b square will be b square only. There you go. This is the answer. Okay. So just I am telling that any kind of problem you can solve in this manner. So first, if you feel like that, okay, there is some equation, I will not say it is an equation. If there is some expression which you can simplify, so first you simplify, then you know that summations can be broken. Summation, or even like here I will not put negative sign, but here I should put negative sign. Summation or negative sign, they can be broken. They can be broken. Okay. So these sign can be broken like this. But multiplication cannot be broken. What I mean to say is that, let's just say expectation of xy is there. So you cannot say that, sir, x and y both are having the randomness, so I will do this. No, you cannot do it directly. Plus sign and minus sign can be broken like this. Expectation of ax1 plus expectation of bx2, and then a and b are constant, so taking outward. But here you cannot do this. Or like this, that, sir, y I will take outward and then expectation of x. Or, sir, I will take x outward and expectation of y. All these things you cannot do. Both are random variable, no? Both are having the randomness. X and y both are having the randomness. If both are random variable, both are random variable, both are having the randomness. So you cannot do that expectation of x multiply with expectation of y. No, this you cannot do. Okay, this will be true, but only in some specific case. Which case, that we will see. But usually you cannot do it. Okay, and y taking outward, all these things you cannot do. So only with respect to the constant you can do, or with respect to plus minus you can do. Is that clear? So everything about expectation operator is clear to you. We started with here. PMF is given, very simple calculation. PDF is given, you need to integrate. Whatever that is given, put it here. This is a function of x. Put the PDF of x. Your job is done. Then we saw this very important property, expectation of y will be a into expectation of x plus b, right? And then we saw these properties which are very simple, very straightforward. Now we are going to start studying about mean, mean square value, variance and everything. Okay, so we will study it, but I need to change the slide. So I will pause the video, I will change the slide, and then I will come back and we will start studying about mean. Okay, we will start from mean. Okay, yeah, thank you. Yeah, welcome back guys. So we have studied about expectation of random variable. Now we need to study about mean of a random variable, right? So what is the mean of a random variable? So mean of a random variable is nothing but it is the expectation of random variable only. Basically, whatever that we have studied till now, that was mean of random variable only. It is just a different name. Okay. So expectation of random variable is nothing but the mean of random variable. So if a PMF is given and if I ask you what is the mean of random variable x, so what you will do? You will take all the values of x and you will multiply with its probability and you will add all of them. And with respect to the PDF, what you will do? So here what you will see, whatever that is written inside, so small x is capital X is written inside, so I will make it small x. Now it is a function of x, so I will put the PDF of x here dot dx and I will integrate for whole limit, right? Now a random variable x is given, another random variable y is defined as y equals to sin x. You need to find the mean of random variable y, but the PDF of random variable x is given. So you are not having the PDF of random variable y. So what you will do? You need to find the mean of random variable y. That means you need to find the expectation of random variable y. So expectation of random variable y. What is y equals to? Y is equals to sin x. Why I am doing so? Because I am not having the PDF of random variable y. I am having the PDF of random variable x. Now what I will do? Expectation operator, what it will do? It will take a integration sign. It will integrate it for the whole limit. Now inside sin capital X is written. So I will write down small sin x. Now this is a function of x. So I will multiply with the PDF of x dot dx. So I will get my answer here. Okay. So whatever the answer is there, that answer I will get. So did you understand this point? That whatever the function is there, this is a function of x, so you will put the PDF of x. If this was a function of theta, you will put the PDF of theta. If this was a function of gamma, you will put the PDF of gamma. Well and good. Now there is something called movement about origin. Okay, movement about origin. So if they are saying that first order movement of random variable x about origin. So what you need to find, focus on this particular thing, movement. Movement means expectation only. Did you understand the meaning of mean? Did you understand the meaning of mean? Mean is just expectation. Now we are seeing what is the meaning of movement. So movement means expectation. Movement of what? Random variable x about origin. And what is the order? First order. First order movement of random variable x about origin. And which order? First order. Okay. What this would be? Second order movement of random variable x about origin. Which order? Second order. So that would be equals to expectation of x square, right? And what this would be, let's write down in a good manner. First order movement of random variable x about origin and power would be 1. So that would be equals to expectation of x and this is equals to minus infinity to infinity x fx of x dot dx. And what is the name of this? Mean, right? Mean of random variable x, right? Now what you are getting here, expectation of x square. So what you will do, whatever that is inside capital X square, so you will make it small x square. This is a function of x, so you will put the PDF of x. Now this is also having a specific name. This was having the name of mean. So this is known as mean square. So this is known as mean square value of random variable x. This name you need to remember. Okay, you need to remember this name. What is the name? Ex square is known as mean square value of random variable x. Although we will write down everything in the conclusion, but you should be remembering that Ex square is known as mean square value of random variable x. Is that okay for you? Will you be able to remember? Surely you will be able to remember. Now nth order movement of random variable x about origin. So movement about origin and it should be nth order. So what that would be equivalent to? X to the power n, since this is a function of x only, dot dx. So this name you need to remember. From this slide, what is important part? This is the important part. Mean square value of random variable x. This is equivalent to ex square. Okay. Now we will see movement about mean. So similar thing is there. First order movement of random variable x about mean. So this ex is shown by mu x. Okay. Mean is actually mu capital X. Really sorry guys. Mean is shown by capital mu x. Okay. This mean can be shown by capital mu capital X. Mu capital X. So mean can be shown by mu capital X. So here also we are talking about mean. So this can be shown by mu capital X. No, this is the mean of random variable y. No. So here I will write down mean of random variable y. This is the mean of random variable y. Mean of random variable y. So here I will write down mu y. This is the mean of random variable x. So I will write down mu x. Right. So mean is actually shown by mu x. Okay. So movement about mean, first order movement about mean. So what is this? Now do you remember the property of expectation operator? Yes sir, I remember the property of expectation operator. The minus sign can be separated. Now you just let me know, will this be a constant value? Sure sir, surely it will be a constant value, no? This mu x is a constant value, no? You will solve this particular integration. Integration is going from minus infinity to infinity. Or you remember the previous example, 1 to 2 x square into x dot dx. These kind of things you are doing, right? Basically x dot fx of x dot dx. So limit of x is constant, no? Limit of x is constant. So this will be a constant value. Mean will be a constant value, no? Mean is surely a constant value, right? We were getting the answer 2.1. So that was a constant value. So mean will be a constant value. And you know that expectation of any constant value will be the same constant value. And what could be expectation of x? Expectation of x could be written as mu x. And what is this? Mu x only. So mu x minus mu x would be equal to 0. So first order movement of random variable x about mean will be 0. This statement could be written and they can ask whether the statement is true or false. So you will be able to tell, yes, the statement is true. First order movement of random variable x about mean. Okay. Now second order movement of random variable x about mean. Movement of random variable x about mean. Which order? Second order. So what this will be equivalent to? A square plus b square minus 2ab. You agree to this point? Right? A square plus b square minus 2ab. Now you know that this can be separated. Now you also know that 2 mu x will be a constant value. So 2 mu x I can take outside. Expectation of x. Is that clear to you? What really happened here? 2 mu is a constant value and expectation of x, right? Now this could be expectation of x square only. Now mu x square is also a constant value, no? Mu x square is also a constant value. So this will be equal to mu x square only minus 2 mu x. Expectation of x could be written as mu x again. So what you are getting? This became 2 mu x square. Simple calculation, very simple calculation. First we solved inside whatever that is there. Then x square, mu x square. 2 mu is a constant value that I can take outside. Expectation of x is mu x. So 2 mu x square you are getting. So what you are getting? Expectation of x square. Expectation of x square minus mu x square. And you can write it down in what manner? Expectation of x square. What is mu x? Basically, expectation of x is mu x, nothing else. Expectation of x is mu x. So I can write it down. Sorry. Expectation of x square minus expectation of x whole square. So this basically, this is coming out to be second order movement of random variable x about mean is coming out to be expectation of x square minus expectation of x square. This is what it is coming out to be, and it has a special name. What is the name? This particular thing has a special name. This is known as variance of random variable x. variance of random variable x. So this is also having a special name, and that is shown by sigma x square. So variance of random variable x is coming out to be ex square minus ex whole square. Will you be able to remember it? Surely you will be able to remember it. So this slide, this point I ask you to remember, and this point I ask you to remember. So let's write down the conclusion. So what was the mean of random variable x? Mean of random variable x was expectation of x only, and you know what expectation operator would do? X fx of x dot dx, taking integration from minus infinity to infinity. What do you mean by mean square value? So it is basically expectation of x square, nothing else. Mean square value is expectation of x square, minus infinity to infinity, x square fx of x dot dx. What was the variance? So variance was given by sigma x square. Variance was given by sigma x square. So you don't need to remember this definition. If you want to remember, you can remember. If you forget this definition, then also it is fine. But whatever the final result we got, what was that? Expectation of x square minus expectation of x whole square. This should be remembered. And there is something called standard deviation. Standard deviation, that is nothing but the under root of variance. So if in the question, if they are asking you standard deviation, what you will do? You will just calculate the variance and then you will take the under root. So it is just the under root of variance. So can I write it down in this manner? Right? So in the question, if standard deviation is asked, you just need to calculate the variance and then you take the under root. So from all the slide, this is what you need to remember. That's it. Mean is expectation of x. Mean square value is expectation of x square. And variance is sigma x square, which is equivalent to expectation of x square minus expectation of x whole square. And your standard deviation is nothing but the under root of variance. Okay, well and good. Now let's take care of this particular expression. Sigma x square is equals to ex square minus ex whole square, right? So from here, what you can write up? From here you can see that ex square is equivalent to what? Ex square is equivalent to sigma x square plus expectation of x whole square, right? So ex square is equals to sigma x square expectation of x whole square. What this was known as? Mean square value, right? Mean square value of random variable x. So let's write down in this manner. This was known as mean square value of random variable x. It is having another name, that is total power of random variable x. Total power of random variable x. Okay, this particular thing, sigma x square, this is known as AC power of random variable x. And here what you have done, you have taken the mean and then you are doing the square, mean and doing the square. So this is known as DC power of random variable x. So this slide is the whole conclusion, whatever that you need to remember. That's it. You will be able to write down the first order movement, second order movement, all these things you will be able to write down. And this is the slide which you need to remember. That's it, nothing else. Mean you remember, mean square value you remember, expectation of x square. Variance you remember, expectation of x square minus expectation of x whole square. Standard deviation is nothing but the under root of variance. Then they can ask in terms of power as well. So you would remember the formula of variance. From there you would see that, sir, if I add both of them, I will get expectation of x square. So expectation of x square is known as mean square value of random variable x. That means it shows that total power of random variable x. And sigma is the AC power and ex whole square is the DC power. Not tough to remember. If you just remember that this is the DC power, then by default it will be the AC power. So DC power plus AC power will be the total power. So either you remember that sigma x square is the AC power, or you remember that ex whole square is the AC power. So any of the thing you need to remember. Okay. So I usually remember this particular thing, that mean square, this is the square of mean, square of mean. So this shows that DC power of random variable x. Okay. And this shows the AC power of random variable x, and this is the total power of random variable x. Well and good. Let's see some questions. PDF of random variable x is given. you need to find its mean and variance. What you need to find? Mean and variance. So first thing is that they have given that random variable x is taking value between -1 to 3, but they did not give the value of k. Can you find out the value of k? Surely you can find out the value of k. Whenever you need to find out any constant or any variable, what property you will apply? You know that total area under the curve will be 1. What is the total area? K into 4. That would be equals to 1. So k is coming out to be 1 by 4. Okay. So this is your PDF. PDF is given, right? And you can define the PDF as well. How you will define the PDF? That fx of x is 1 by 4 when your random variable x is taking value between -1 to 3. Otherwise it is 0. Right? Now what you need to find? You need to find the mean of random variable x. So expectation of x will be equivalent to -infinity to infinity x fx of x dot dx. Now x is taking, actually it is taking value, basically fx of x is non-zero between -1 to 3. Look, x could be non-zero between -infinity to infinity. This x could be non-zero between -infinity to infinity. But fx of x is non-zero between -1 to 3. So this multiplication will be non-zero between -1 to 3 only, right? There x will remain as it is because this is the variable x, but fx of x is 1 by 4 dot dx, right? So 1 by 4 x square by 2 -1 to 3. So 1 by 8 9 minus 1. So mean is coming out to be 1. So what is the mean? So here what I can write down, expectation of x, or sometimes you represent it as mu x as well, or sometimes you represent it as x bar as well. Mean of random variable x bar, that is coming out to be 1. Now what I need to find? I need to find the variance. So first thing what I will do, I will write down the formula that variance of random variable x is given as expectation of x square minus expectation of x whole square. So this particular thing I am already having, but I need the expectation of x square. So now my expectation of x square I need to calculate. So what that would be equivalent to? -infinity to infinity x square fx of x dot dx. So your fx of x is non-zero between -1 to 3. X square could be non-zero between any limit, but fx of x is non-zero between -1 to 3. So x square divided by 4 dot dx, right? So what you are getting? X cube divided by 12. So 1 by 12 x cube -1 to 3. So 1 by 12 27 minus 1. 1 by 12 x cube 26 by 12. 26 by 12. So 13 by 6. 13 by 6. It is coming out to be 13 by 6. 13 by 6. Right? So what is your sigma x square now? Sigma x square is 13 by 6 minus, this was 1. So 1 square will be 1 only, no? 1 square will be 1 only. So what is the answer you are getting? Did I do the calculation correctly? Yeah, this would be plus. I was thinking that there is something wrong, right? Here, basically this will be minus and then minus 1. So this will be plus, no? 28 by 12. You will be getting 28 by 12. Okay. So 7 by 3. 7 by 3 minus 1 square. So what we are getting? 4 by 3. So your variance is coming out to be 4 by 3. This is the answer, right? And what was the mean? If I need to write down the mean as well, so your mean was actually coming out to be 1. So very simple thing, very simple thing. Okay, also this is a standard PDF. Okay, we will study about it in the next lecture only. We are going to study about some standard PDF. This is known as uniform PDF. Here you can see that fx of x is having the same value, no? It is having the value 1 by 4. It is not a function of x. It is nothing. It is a constant value. It is a uniform value. So this is known as uniform PDF of random variable x, which we are going to study in the next lecture. Okay, so for this there is a certain formula which I will ask you to remember as well. B minus a whole square divided by 12. So what you are getting? 16 by 12, 4 by 3. So that would be your variance. So your variance is 4 by 3 only. So we will remember the standard formula for this particular PDF as well. Okay, so there I will ask you to derive everything on your own. So all the derivation, all these steps you can do on your own. In place of 3, I will be putting B. In place of minus 1, I will be putting A. Okay. Try this question on your own. You can surely do it. Have some patience. You already know the mean. Expectation of y will be equals to expectation of ax plus b, and you need to find the variance as well. So how will you find the variance? Have some patience. You will be surely able to do it. Just write down the simple formula, the way formula says, and try doing in the same direction. Okay, I will have to take a break because I am having a cold. Okay, so I will take the break in 30 minutes or 40 minutes. Right now I am taking the break after 20 minutes, but in between 30 to 40 minutes I will be taking the break because I am having the cold. Okay, so you try doing it on your own. Yeah, so did you try this question? What you need to find? Y is equals to ax plus b is given. First you need to find is that mean of random variable y. So what will be the mean of random variable y? Mean of random variable y could be written as mean of expectation of random variable y. So expectation of random variable y could be written as expectation of ax plus b as well. And you know that it can be broken down into a into expectation of x plus b, because b is a constant, a can come outside, a into expectation of x plus b. So this is the first step, that is that expectation of y or mean of y is equals to a into expectation of x plus b. Constant can come outside, constant can be taken as common, and this is already a constant value, so this will be having expectation of b only, right? What we need to find? We need to find the variance now. So variance of y would be equals to what? Mean square value of y minus expectation of y square. So this particular thing we are already having, we need to find this particular thing. So what we need to find? Expectation of y square we need to find. Expectation of y square we need to find. Can this be written as expectation of ax plus b? Surely it could be written as expectation of ax plus b whole square as well. So expectation of a square plus b square plus 2abx, right? A square expectation of x square plus expectation of b square will be b square only plus 2ab expectation of x. Very simple, right? Expectation of y square I need to find ax plus b whole square. So a square b square plus 2abx. Then what I will do? A square I can take common. So a square expectation of x square plus expectation of b square will be b square only plus 2ab expectation of x, right? So this is your expectation of y square. Now I need to find sigma y square. So sigma y square is a square expectation of x square plus b square plus 2ab expectation of x, right? Minus bracket sign. Basically I am putting down this particular thing here. Expectation of y square I have put. Now expectation of y. What was the expectation of y? A into expectation of x plus b whole square, right? So what you are getting? A square expectation of x square plus b square plus 2ab expectation of x minus a square this square. Look, there is a minus sign, although in the bracket what will come? Everything will be positive, right? In the bracket everything will be positive. So if there is a minus sign and if I open the bracket, then every positive sign will be converted to the negative sign. So a square plus b square plus 2ab expectation of x. Did you understand this point? Did you understand this equation? Very simply, expectation of y square I have put, which is this one. Then expectation of y whole square I need to put. So expectation of y is a into expectation of x plus b. Then this square plus 2ab expectation of x. Then there is a minus sign. So with the minus sign you open it up. So what do you think? this and this is getting cancelled out. B square and B square is getting cancelled out. So what is the answer you are getting? Oh, so sigma y square, what I am getting? A square expectation of x square minus A square expectation of x. I think I should add a page. Okay, let's not. So let's write down the last step on the next page only. So in the last step, what I can see, sigma y square is coming out to be A square expectation of x square, A square expectation of x square plus, not plus, minus A square expectation of, what you are getting, minus A square expectation of x whole square. Is that fine for you? Right. Now what you can do, you can take A square common. So what you are getting? If I take A square common, so expectation of x square minus expectation of x, expectation of x whole square. This is what I am getting. So your sigma y square is coming out to be A square into, what is this? Sigma x square, right? This is sigma x square. There you go. So your y was given as ax plus b. You need to write down the mean. What you will do? Mu y is equals to a mu x plus b. Mean of y would be equals to a into mean of x plus b. And if you need to write down the variance, so variance of y would be equals to a square sigma x square. So variance will kill the constant values. What does variance do? Variance will kill the constant value. But mean, what mean will do? Mean will not do anything with the constant value. Mean will not do anything with the constant value, but variance will kill the constant value. Along with that, here this was the constant value, it will make it square as well. So this is the conclusion that we have made. And from here, if someone asks you what is the value of expectation of y square, so you will simply say sigma y square plus mu y square. So you can do the square and you can get the value, right? So expectation of y square, we are not remembering any answer, but here we have remembered answer, or you can say it is kind of method, you can say. What does the method say? The method simply says one thing, that is mu I, expectation of y you need to calculate, that means a into expectation of x plus b. If you need to calculate the variance, so variance of y would be equals to a square into variance of x, that's it. And if you need to calculate the mean square value of y, what is this? Mean square value of y, or you can say total power of y. So you are having the AC power, you are having the DC power as well. From there you can calculate the mean square value as well. Well and good. So this is the conclusion that we have written. Mu y would be equals to a into mu x plus b, and sigma y square would be equals to a square sigma x square. Y equals to minus 2x plus 3 is given, mu x is given, sigma x square is given. You need to find sigma y square, you need to find mu y, and you need to find that total power of random variable x divided by total power of random variable y. So let's find out all these things. You know that mu y square would be equals to a square. What is the value of a? Minus 2. So a square sigma x square. Well and good. Okay. So 4 into sigma x square was 4 only. So answer is 16. So sigma y square is 16. What is your mu y? Mu y is minus 2 mu x plus 3. So minus 2 into 3 plus 3, that is coming out to be minus 3. So what all answer you have got? Till this point we have got that sigma y square is coming out to be 16 and sigma and mu y is coming out to be 3, minus 3, right? Now total power of random variable x. Total power of random variable x means expectation of x square. What that would be? Sigma x square, that is 4, plus mu x square, that is 9. You remember this thing, no? AC power plus DC value whole square. So this is the DC power. DC value, I just said this DC value. Average, mean. Basically there are three kind of name: mean, you can call it average as well, you can call it DC value as well. Okay, this is equivalent to expectation as well, and this is equivalent to expectation of x mu x. So these are the names. So this is how I remember: mean, square of mean, or you can say square of DC value. This is nothing but the DC value, right? So what you are getting: 4 plus 9, 13. And expectation of y square would be equals to what? Sigma y square, that is 16 plus 9, 25, right? 16 plus 9 mu y square. So minus 3 square will be 9, so 25. So here what is the answer you are getting? 13 by 25. Total power of random variable x divided by total power of random variable y. 13 by 25, this would be the answer. Well and good. Okay then. A random variable x is taking values between 1 to 5 with probability shown. You need to find the mean and variance. So first let's find the mean, expectation of x. So you know how do we find out the mean? Take the value, multiply with the probability. 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 What you are getting? 0.5, 0.5, 1, 1, 3. Expectation of x is coming out to be 3. Well and good. Okay. Take the value, multiply with the probability. Take the value, multiply with the probability. 3 into 0.4, 4 into 0.2, 5 into 0.1. Right. Now what I need to find? Variance. So for variance, what I need to do? Expectation of x square minus expectation of x whole square. So how will you calculate expectation of x square? The way you calculated expectation of x, right? Expectation of x square. How will you calculate? Here what you will do? You will take the value of x square and then you will multiply with the probability. Basically x is given, no? Now what I will do? I will make a table where x square I will write down. 9, 16, 25. And what will be their this is x square. And what will be their respective probabilities? That would be the same only, no? Basically if x is taking value 1, then x square will take the value 1. So what is the probability of x square taking value 1? That is equivalent to probability of x taking value 1. That would be 0.5. Are you able to understand this point? What I am asking, what is the probability of x square taking value 4? So that would be equivalent to probability of x taking value 2. Actually it would be plus minus 2, right? X could be plus minus 2. But you know that this is already equals to 0. So probability of x equals to 2 is 0.2. So probability of x square taking value 4 is equals to 0.2 only, no? Are you able to understand this point? So this table will not change, only the x square value I am changing. So this probability will remain the same. Probability will remain the same. So what will be your expectation of x square? So what you are doing the square and then multiplying. 0.1 plus 4 into 0.2, 0.8, 9 into 0.4, 3.6, 16 into 0.2, 3.2, 25 into 0.1, 2.5. Is that clear to you? Right? Well and good. So you will not have to make this table again and again, right? Without even making this table again and again, you will be able to tell the answer. Say yes or no. Okay. So what you are getting? 9, 45, 5, 7, 10.2. Let me do the calculation again. 9, 45, 45, 5, 7, 7, 8, 9, 10, 10.2. Yeah, expectation of x square is coming out to be 10.2. So what they are asking? They are asking sigma x square, that is 10.2 minus 3 square, that would be 9. So that would be equivalent to 1.2. So here the answer is 1.2 and here the answer was 3. Mu x was 3. Okay. So variance was 1.2 and mean was 3. Is that clear to you? So this is how you can calculate. Very easy. In case of PMF also it is very easy. In case of PDF as well it is very easy. Everything is very easy here. Next question, PDF is given. 1 by 2 mod of x e to the power minus mod of x. You need to find the mean, variance and 17th order movement about origin. Okay, all these things you need to find out. So let's go one by one. First thing, let's find out the mean, expectation of x. So that would be equivalent to minus infinity to infinity x fx of x dot dx. Here x is going from minus infinity to infinity only. Here they did not mention the limit of x, no. So by default you will say that x will go from minus infinity to infinity only. Okay, so here it will go from minus infinity to infinity. Minus infinity to infinity. 1 by 2 is a constant value which I can take outside. So what I will do is that 1 by 2 will be a constant value, minus infinity to infinity x mod of x e to the power mod of x dot dx. Do you remember something, even function, odd function? Is it a even function or odd function? Odd function, right? This is a odd function, no? I'm only talking about this thing. I'm only talking about this particular thing. If you just calculate this integration, what will be the answer you will be getting? Basically, what I mean to say is that, can you break down this limit into two? That minus infinity to infinity. First, I am breaking down as minus infinity to 0. Okay. So minus infinity to 0, I am putting the limit of x. What does that mean? That means here x is negative. So how will the mode open? The mode will open with the negative sign, right? So this will be x square e to the power x dot dx. Mode will open with the negative sign, so here negative sign. Plus again 1 by 2, limit goes from 0 to infinity. Now x is positive, so mode will open with the positive sign. Right? Now will you solve this integration? It will take a lot of time. So what you need to think, here in place of x, if I put minus x, in this function, in place of x, if I put minus x, what I will get? The same function again, no? So basically this is, sorry, not the same function, just the negative of that. So basically this is a odd function. And if it is an odd function, what does that mean? That means the integration will be 0. Do you know that calculating the whole area of odd function will be equals to 0? Odd function. Is this a odd function? Yes. Whatever that you see on the positive side, just the negative I am seeing. Take one mirror image and then another mirror image. Yes, it is a odd function. What does that mean? The total area will be whatever the positive area you are getting, the same negative area you are getting. So total area would be 0. Are you able to understand this point? Or basically what you can do is that here in place of x you can put minus x. So you will get the same thing. What I mean to say is that here in place of x you will put minus t. So what you will get? Dx equals to minus dt. And how the limit will go? If x is minus infinity, then t will be plus infinity. And if x is 0, then t will be 0. So, and next what you are putting? In place of x you are putting minus t. So here you will get t square e to the power minus t dot dt 1 by 2. Already there is a negative sign. Now this negative sign, what it can do? It can interchange the limit. So limit will go from 0 to infinity. Right? And in place of t I can put x as well now. Basically t is just a variable, no? So in place of t I can put x. So in place of t now I can put x. So x square x dot dx. Right? Something wrong I have done. ये क्या हो गया? Add कैसे हो गया भाई? Okay, yeah. Already there was negative sign. So negative sign became plus. Another negative sign would be there. Basically, in place of dx, you would put dt here, no? What I mean to say, this is a very simple, very simple integration. So already there was minus 1 by 2. You are putting the limit. From where you will put the limit? If x is equals to minus infinity, then t will be equals to plus infinity. If x is equals to 0, then t will also be equals to 0. T square. In place of t, in place of x, what you need to put? Minus t. And in place of dx you need to put minus dt. So this minus became plus. Now what I need to do, I just need to interchange the limit. I need to make the limit from 0 to infinity. So here if I need to make the limit 0 to infinity, then negative sign would come, right? So negative sign would come. So limit would go from 0 to infinity. So this is 0 to infinity. Okay. So this is same as this thing. So if you add all both of them, what you will get? 0 only. Or you can simply see this is a odd function. Integration of odd function for complete limit would be equals to 0 only. That's it. Very simple thing. Very, very straightforward. If you have covered signal system, if you have covered basics of mathematics, then you would know that odd function will throw 0 integration, right? So expectation of x is equals to 0. Okay. Yeah. So this is the thing. Now we need to calculate the variance. So for calculating the variance, what I need to do? Expectation of x square minus expectation of x whole square. So what would be your expectation of x square? So expectation of x square would be equivalent to minus infinity to infinity x square fx of x dot dx. So minus infinity to infinity x square. What is your fx of x? So 1 by 2 I can take outside, mod of x e to the power mod of x dot dx. Mod of x e to the power minus mod of x dot dx. 1 by 2 is already outside dot dx. Is that okay for you? Now you know that this is even function. This is even function, because in place of x, if you put minus x, you are getting the same expression. So if it is a even function, can I write it down in this manner? 0 to infinity x cube e to the power minus x dot dx. Did you understand this point? This is a even function, no? So at least this much point you agree, right? If this is a even function, that means whatever the integration it will throw for the positive value, the same integration it will throw for the negative value as well. That means I can break the limit from 0 to infinity, multiply with 2. 0 to infinity, multiply with 2. So x square here, and then mod of x, the same function. Now you know that x is positive here. You are putting the limit from 0 to infinity. So basically x is positive. And if x is positive, that means mod of x will open with plus x. So what you are seeing here? 0 to infinity x cube e to the power minus x dot dx. So this is what you need to calculate now. Is that clear to you? So this is our question now, that this is something that I need to calculate. If I am able to calculate expectation of x square, if I am able to calculate this particular integration, then my job is done. So we need to go to now signal system. Do you remember what was the Laplace transform of e to the power minus t ut? That was 1 upon s plus 1. What was the Laplace transform of t e to the power minus t ut? That was 1 upon s plus 1 whole square. What was the Laplace transform of t square e to the power minus t ut? That was 2 s plus 1 whole cube. And what was the Laplace transform of this particular thing? Basically, you just need to differentiate and then add a negative sign. So 6 s plus 1 to the power 4. Right? Now you know that Laplace transform is given as, how it is given? Laplace transform is given as minus infinity to infinity x of t e to the power minus st dot dt. Right? Now here in place of s, if I put 0, what I will be getting? Minus infinity to infinity x of t dot dt. What is our x of t now? Minus infinity to infinity t cube e to the power minus t ut dot dt. Because of this ut, the limit can change from 0 to infinity. So 0 to infinity t cube e to the power minus t dt. Say yes or no. So you are finding the integration of t cube e to the power minus t dt. What that is coming out to be? Whatever the Laplace transform you are having, in place of s you put 0. So in place of s, if I put 0, 6 upon s plus 1 to the power 4. In place of s, if I put 0, what I will be getting? 6. So what is the answer you are getting? 6. So t cube e to the power minus t dt is giving you 6. So x cube e to the power minus x dx, what it will give you? 6 only. There you go. So what is the answer you are getting? 6. This is the answer. So this is the answer of your variance. So sigma x square is equals to ex square, that is 6, minus 0 whole square. So that would be equivalent to 6 only. There you go. This is the answer. So variance is 6. What was the mean? 0. What do you think? What will be the answer of this one? 17th order movement about origin. Do we have the page? No, we don't have the page. So 17th order movement about the origin. What you need to find? So let's do it here. It is very simple actually. Movement about origin and 17th order. So what that would be equivalent to? Minus infinity to infinity, x to the power 17, x to the power 17, 1 by 2, 1 by 2 outside, mod of x, e to the power minus mod of x dot dx. Now let me know what is this, even or odd? Odd, right? If you put in place of x, if you put minus x, what will happen? Minus sign will come outside. Positive sign, minus sign will come outward. So this is an odd function. And if it is an odd function, that means integration will throw 0. That's it. 17th order movement about origin. That would be equivalent to 0 only. Well and good. Okay. So all answer we have put 6 here, 0 here, and for this one as well, 0 answer. Okay. Let's go to this question. Random variable x represents the number of times dice needs to be thrown till 3 is observed for the first time. Find the expectation of x. What it is saying? What do you think? What is your random variable x here? Random variable x is number of times dice needs to be thrown till 3 is observed. So number of times dice needs to be thrown till 3 is observed. This is your random variable x. Now what should be your sample space? What do you think? So if I throw the dice one time, basically what you are doing, you are throwing the dice until 3 is coming. So you throw the dice, on the first time only 3 will come. So what you will do, you will stop here. Say yes or no. So how many times you throw the dice? Only once. Are you able to understand this point? Then what you did? You throw the dice. On the first time 3 did not come, but on the second time 3 came. So how many times did you throw the dice? 2. Now what you did? You throw the dice. First time 3 did not came. Second time 3 did not came. Third time 3 came. So number of times you throw the dice is 3. So you are doing the experiment until you get 3. So what may happen? Then you get 3, and this process may keep on going. So x can take value 1, 2, 3, 4 and so on. So what do you think? What will be the probability of a random variable x taking value 1? That means you throw the dice one time and you get 3. Let me repeat the statement again. You throw the dice one time and you get 3. What is the probability of that? 1 by 6. Now what is the probability of random variable x getting value 2? You throw the dice 2 times. On the first dice, you throw the dice 2 times. You throw the dice 2 times. On the first dice, you do not get 3. Apart from 3, any number you can get. On the second dice, you get 3. On the first dice, you should not get 3. That means any number you can get. 1, 2, 4, 5, 6. Any number you can get. 5 by 6. And on the second dice, you need to get 3. So 5 by 6 into 1 by 6. Probability of random variable x taking value 3. That means 3 times now. On the first dice, you should not get 3. Any value but not 3. On the second dice as well, any value but not 3. On the third dice, 3. Right? And so on. In that manner, it will keep on going. So this is your probability of taking all these values. What you need to find? You need to find the expectation of x. So expectation of x would be equals to what? If random variable is taking value 1, probability is 1 by 6. If random variable is taking value 2, probability is, if random variable is taking value 2, the probability is 5 by 6 into 1 by 6. If random variable is taking value 3, then probability is 5 by 6 into 5 by 6 into 1 by 6. If random variable is taking value 4, then probability would be 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6. So if you have enough practice, then directly this step you will be writing in the examination hall. You will understand, okay, x is the number of times dice is thrown. So 1 time, 2 time, in that manner I will throw the dice. So in 1 time only if I am stopping, that means I am getting 3. In 2 times if I am stopping, that means first dice I did not get 3, second dice I got 3. So 5 by 6 into 1 by 3. Sorry, 5 by 6 into 1 by 6, and in that manner you will keep on going. So this is the last step that you are getting, expectation of x, right? So I will just copy it. You just need to solve this summation now. So this has become a question of aptitude. So what you will do, 5 by 6 into expectation of x. This is what I will do. So basically I will multiply this first term with 5 by 6. So what I will be getting, 5 by 6 into 1 by 6, because there are infinite terms, no? Now I will multiply this second term with 5 by 6. So what I will be getting, 2 into 5 by 6 into 5 by 6 into 1 by 6. This term is being multiplied with 5 by 6. Now this term will be multiplied with 5 by 6. Basically all the terms are being multiplied with 5 by 6. So all the terms are being multiplied with 5 by 6. So now 3 into 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6, and so on. Now subtract both of them. What you are getting? What I am doing, I am subtracting both of the equation. Equation 1 minus 2. So expectation of 1 x divided by 6, that would be equals to 1 into 1 by 6 plus 2 into 5 by 6 into 1 by 6 minus 1 into 5 by 6 into 1 by 6. So that would be equals to 5 by 6 into 1 by 6 plus 3 minus 2 will be 1. So 5 by 6 into 5 by 6 into 1 by 6, and in that manner it will keep on going. Okay. So what is the answer? A upon 1 minus r. What is the value of r? 5 by 6. Right? A upon, what is the value of r? R is 5 by 6, no? So if you multiply 5 by 6, then again multiply with 5 by 6. So a upon 1 by 6, a upon 1 minus r. R value is 5 by 6. So 1 by 6 divided by 1 by 6. What is the answer you are getting? 1. So expectation of x divided by 6 is equals to 1. That means expectation of x is coming out to be 6. This is the answer. So what they are saying, that means in 6 throws it is expected that you will get 3 at least once. In 6 throws it is expected that you will get 3. And just think about it, no? Like on the dice, how many numbers are there? 6 numbers are there. So expectation, what expectation will do? Expectation will say that I will take the worst case, that on the first dice you are getting 1, on the second dice you are getting 2, on the third dice you are getting 3, on the fourth dice you are getting 4, on the fifth dice you are getting 5, on the sixth dice you are getting 6. That means what you are getting? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the general case expectation will take. So it is surely expected, no, that in 6 dice, in 6 throw, at least you will be getting a 3. So what they are saying, x represents the number of times you need to throw the dice. That means it is expected that you need to throw the dice 3 times such that 3 is observed for the first time. Like, are you able to understand interpret the meaning of expectation here? This is what I am saying. Just try interpreting the meaning of expectation here. Let's just say I design a dice where I can get 8 values. 1 I can get, 3 I can get, 4 I can get, 5 I can get, 7 I can get, 8 I can get, 9 I can get, 11 I can get. Yeah, so these values I can get. Now if I ask you, find the expectation of random variable x, and random variable x is such that it represents the number of times dice needs to be thrown such that 4 is observed for the first time. What will be the answer? Expectation of x will be 8 only. Why 8? because 8 values can come. So although we will not use our intuition in the examination, we will solve by this. But once the answer comes, we can match it with the intuition. Are you able to understand this point? Okay. Let's go to the next question. Not the next question, next concept actually. Okay. So now we have studied, we were studying about movement about origin. Now we will study about joint movement about origin. Joint movement of a random variable x and y about the origin. So joint movement of order 1, 1 of random variable about the origin of random variable x and y. So what they are saying, movement about the origin, that means x minus 0, y minus 0. What is the order? 1 of random variable x and y. So this is given by expectation of xy. So what was your expectation of x? Expectation of x was minus infinity to infinity x fx of x dot dx, right? So what would be your expectation of xy? Xy, whatever that is written inside, capital, small xy. Now, what do you think what should come? What kind of PDF should come here? Joint PDF will come, right? Because this expectation you are calculating for random variable x as well, for random variable y as well. So here what will come? Joint PDF will come. Dot dx dot dy, and here you will put the limit of x as well, you will put the limit of y as well. We are going to solve very good questions here, okay? So what you understood? Expectation of xy, expectation of xy, it is known as rxy as well, okay? What it is known as rxy. What I will do? Minus infinity to infinity, minus infinity to infinity, xy, fxy, x comma y, dx dy, and it is having a specific name which is known as correlation between random variable x and y. Correlation between random variable x and y. So this particular formula is important. Is that okay for you? Correlation between random variable x and y is given by exy, that is shown by rxy, minus infinity to infinity, xy, fxy, x comma y, dx dy. Is that okay for you? All good? Joint order movement of order rk about the origin for random variable x and y. So about the origin, you need to find the movement of order r and k. What that would be equivalent to? You will take the limit of x and y. You will take the limit of x and y, x to the power r, y to the power k, fxy, x comma y, dx dy. Very rare chance that anyone would ask it, but still if in the examination they are asking it, you should be having the concept that you should be able to calculate this particular integration. Okay, so very easily you will be able to calculate this particular integration. But from this slide, this is the important part. Correlation between random variable x and y is given by xy, fxy, xy dot dx dy. Okay, and the notation is rxy. So this notation should also be clear, and this definition should also be clear. Joint order movement about mean of order 1, 1 for random variable x and y. About what? About mean. Okay. So what will be the mean of random variable x? The mean of random variable x is mu x. And what will be the mean of random variable y? That will be mu y. Okay. So what they are asking? Movement about mean. Movement about mean. What is the order? 1. Movement about mean. What is the order? 1. So it could be given as x minus mu x into y minus mu y. So let's solve it inside. What you are getting? X into y, x into mu y minus mu x into y plus mu x mu y. So what you are getting? Expectation of xy minus mu y is a constant. So mu y expectation of x minus mu x is a constant. Mu x expectation of y. Mu x mu y both are constant. Well and good. So expectation of xy minus mu y, expectation of x is mu x minus expectation of y is mu y plus mu x mu y. What you are getting? This and this is getting cancelled. So what you are getting? Expectation of xy minus mu y could be written as expectation of y and mu x could be written as expectation of x. So I can write it down, expectation of x into expectation of y. So this is what it is coming out to be, which is first order 1,1 order movement of random variable x and y about mean. So this is how it is coming out to be, right? And again this is having a specific name. So this is known as covariance of random variable x and y, that is given by cxy, sometimes covariance, or sometimes sigma xy as well. Whatever the notation they use, they will write it down, covariance sigma xy or cxy. Screen इतनी white क्यों लग रही है भाई? Why this screen is looking white? Okay, so cxy or sigma xy, this is what they will write down. That is coming out to be exy minus ex into ey, right? And can I write it down in which manner? In this manner as well, that rxy minus mu x mu y. There you go. So this particular answer is not answer, this particular box is also important. Here if I don't add it in a box, then also it is fine, whatever the answer you are getting, but let's keep the box. But this is the final conclusion that is important, and this is the final conclusion that is important. So what we understood, covariance and correlation, the name looks same, okay? Covariance and correlation, the names are kind of same, but they are totally different. One is expectation of xy, one is expectation of xy minus expectation of x dot expectation of y. Okay, so covariance and correlation, if this is star important, then this is 3-star important. Okay, like we will be talking about covariance more. So covariance is the boss, this guy is the boss, because covariance is already having correlation. Okay, so covariance is the boss. So correlation between random variable x and y is given as expectation of xy, and that is given as minus infinity to infinity minus infinity to infinity xy fxy x comma y dx dy. What do you understand by covariance? So covariance is sigma xy, or it could be written as cxy as well, and that is exy minus ex ey. That is, what is your exy? Your exy is rxy minus mu x mu y, which is equals to cxy, right? Now correlation coefficient, there is something called correlation coefficient. This can also be asked in the examination, correlation coefficient. So the name is correlation coefficient, that means you think that it should be related with correlation. No, correlation coefficient is actually related with covariance. So correlation coefficient is actually covariance of random variable x and y divided by standard deviation of random variable x and standard deviation of random variable y. Okay, sigma xy divided by sigma x into sigma y. What is sigma y? Standard deviation of random variable y. What is sigma x? Standard deviation of random variable x. What is sigma xy? Covariance of covariance between random variable x and y. Okay, you know the definition of covariance as well, you know the definition of correlation as well, everything you know. So this is the slide complete conclusion. So with respect to random variable x, what you define? Mean and variance. With respect to random variable y, what do you define? Mean and variance. With respect to random variable xy, what you will define? And here I will write down that you define fx of x as well, and here you define fy of y as well. But with respect to x and y, what you will define? Joint PDF, and along with that, what you will define? Rxy, and you will define sigma xy, or you call it covariance of random variable x and y. So this was your correlation and this was your covariance. Correlation, covariance. Covariance is the boss. Covariance is the boss. Second guy is the boss. So exy minus exey. Okay. Correlation coefficient is sigma xy divided by sigma x dot sigma y. The name is correlation coefficient, but it is associated with covariance only. Well and good. Now, W is equals to AX plus BY is given. You need to find the mean square value and variance of W. What you need to find? Mean you need to find. What is X? X is a random variable. This is a constant. This is a constant. Constant. X is a random variable. Y is a random variable. What we need to find? We need to find the mean of random variable W. Then we need to find mean square value. That means, and then we need to find variance. So these things we need to find. So do it on your own. I will take a pause. You can surely do it on your own. Whatever that we have studied, in that manner you try doing it, everything will be clear to you. Okay. So you try doing it on your own. I will take a break and then I will come back and I will solve it. Yeah, welcome back. So did you guys try this question? We need to find expectation of a random variable W. So that could be equivalent to expectation of random variable AX plus BY. So A is a constant. So A into expectation of X प्लस B इंटू एक्सपेक्टेशन ऑफ वाई. यार ये टेढ़ा कैसे जा रहा है सब. B इंटू एक्सपेक्टेशन ऑफ वाई. So that would be expectation of X could be written as mu X plus expectation of Y could be written as mu Y. So expectation of W is coming out to be A mu X plus B mu Y. So everyone would have done it, right? Next we need to find mean square value. So for finding mean square value, what I will do? I will do the square of this one. A square plus B square plus 2AB, right? Square I am doing. So what you are getting? A square expectation of X square plus B square expectation of Y square plus 2AB expectation of XY. Say yes or no. This is the answer. No need to mug up. Okay. No need to mug up. Very easily you can derive it. If this question they are asking, very easily you can derive it. If this question they are asking, very easily you can derive it. Right. Just constant value are taking outside, very easily you can do it. But now, whatever the result we are getting for this one, what we need to find? Variance. So that result we will remember. So what we need to do? This minus this. This is what we need to do, right? Expectation of W square minus expectation of W whole square. So expectation of W square is given as A square expectation of X square plus B square expectation of Y square plus 2AB expectation of XY minus. You need to do the square of this one and then you need to subtract it. So what will be the square of this one? A square. Basically I am doing the square of this one. A square plus B square plus 2AB mu X mu Y. Right? And then I will open this bracket. That means all the positive sign will become negative sign. So what you are getting? A square expectation of X square minus mu X square. Expectation of X square minus mu X square plus B square. Expectation of Y square minus mu Y square plus 2AB. Expectation of XY minus mu X mu Y could be written as expectation of X into expectation of Y. Do you recognize this particular thing? Expectation of X square minus expectation of X whole square. What is this? Sigma X square, right? Plus B square. What is this? Sigma Y square plus 2AB. What is this? Covariance of random variable X and Y. Covariance. So, since we are writing down everything in terms of sigma, so here I will write down covariance of random variable X and Y. So this is your final answer. Is that clear to you? So expectation of W, no need to mug up. Expectation of W square, no need to mug up. Final answer, you need to remember. What you will do? This slide is of no use. So do you remember W is equals to, not W, Y equals to AX plus B. Here Y is already given, so I will use something different. Let's use Z equals to AX plus B. So what was your sigma Z square? So sigma only cares about randomness. Constant value was there, sigma x square. B is there, it is not having any randomness, it is a constant value, right? Since it is a constant value, it is gone. So sigma Z square was A square sigma x square. Here AX plus BY. So A is also having randomness, B is also, sorry, X is also having randomness, Y is also having randomness. So A square sigma x square plus B square sigma y square plus 2AB sigma xy. So it's like the formula of A square plus B square plus 2AB. So A square sigma x square plus B square sigma y square, and 2AB is having both x and y. That means I will use here covariance. So what is this? Always remember, this is the covariance. And don't forget what is sigma xy equals to. Sigma xy is equals to EXY minus EX into EY. Okay, very simple thing, very simple. Well and good. So let's make this question more challenging. What we can do, one of them we can make negative, 3x minus 2y. W is equals to 3x minus 2y. This is what we are doing. So x mod is given. What is that? What does that mean? Here this is the meaning. Here this means expectation of x. Although in the theory it will be written. If this question is coming in the examination hall, they will write down that it is the mean square value. That means it is expectation of x square. Okay, this is given. And what is this? This is covariance. So they will write it down in the examination. So all these things are given. What you need to find? You need to find the mean square value and variance of W. So first thing, I will think about mean. So what I will think? 3 into expectation of x minus 2 into expectation of y. So 3 into expectation of x I already know, minus 2 into expectation of y. Expectation of y is 2. 3 into expectation of x is 1 by 2, minus 2 into expectation of y is 2. So 3 by 2 minus 4. What that would be? Minus 5 by 2. Mean square value. If they are asking me mean square value, do I remember any formula for this? No, I don't remember any formula. So what I will do? Simply expectation of W square I will do. So A square plus B square minus 2AB. So 12 xy. Right? So what I will be getting? 9 into expectation of x square plus 4 into expectation of y square, 12 expectation of xy. So you are having this value, expectation of x square you are having, expectation of y square also you are having, but expectation of xy you are not having. So for that I can use the covariance formula. So what does the covariance says? Covariance says that I am equals to expectation of xy minus expectation of x into expectation of y. So covariance is given, that is minus 1 by 2 under root 3. So that would be equals to E of xy minus, what is your E of x? 1 by 2. What is your E of y? 2. So E of x is 1 by 2. E of x is 1 by 2. E of y is 2. So what you are getting? Expectation of xy is equivalent to 1 minus 1 by 2 under root 3. So this is your expectation of xy. Okay. Although this was not asked, but here it will be used. So our expectation of W square, that is coming out to be 9 into 5 by 2. 9 into 5 by 2 minus, sorry, plus 4 into 19 by 2. minus 12 into this value is 1 minus 1 by 2 under root 3. Okay, 45 by 2 plus 38 minus 12 plus 6 by under root 3. So whatever you get, you will get it. Okay, you can solve it, right? So I will write down the answer. I will solve it and I will write down the complete answer. Yeah, so the answer we are getting is 59.16. Okay, next we need to find variance. So although we are having the value of EW square as well, we are having the value of EW as well. So we can easily find the variance, but let's apply the formula that we remember. So variance formula, what we remember? A square sigma x square. Basically, what is your W? W is given as 3x minus 2i, right? 3x minus 2i. So sigma W square would be 9 sigma x square plus minus 2 square, that would be 4 sigma y square plus 2ab. But here there is a negative sign, no? So this will also be negative. So 12 cxy. Say yes or no? Understood? Did you understand this point? This formula I am applying, nothing else. This formula. A square sigma x square plus b square sigma y square plus 2ab sigma xy. So 9 sigma x square plus 4 sigma y square minus 4 into 3, 12 cxy, right? So directly I will put 9 sigma x square. Okay, we are not having the value of sigma x square as well. So from here we need to find the values of sigma x square and sigma y square as well. So what is the value of sigma x square? 5 by 2 minus 1 by 4, right? 5 by 2 minus 1 by 4. And what will be the value of sigma y square? So this will be 19 by 4. No, sorry, 9 by 4. What would be your sigma y square? That would be 19 by 2 minus 4. 11 by 2. Root 10. Yeah. So 9 by 4, 11 by 2. Yeah. So 9 into, this is 9 by 4. Plus 4 into 11 by 2. Minus 12 into minus 1 by 2 under root 3. Well and good, right? So you will solve this, you will get the answer. Another answer could be simply, I could have done this square minus this square. This also I could have done. That means 59.16 minus, what answer I was getting here? Minus 5 by 2. So plus 5 by 2. So this is 2.5. So 51.96 plus 2.5. So 6, 4, 4, 54.46 I will be getting. 54.46. So let me solve this one and let me check if 54.46 I am getting or not. Yeah, actually we did a mistake here, right? Blunder it was. Expectation of W, what was expectation of W? Minus 5 by 2, no? So minus 5 by 2 whole square. So this would have been the answer. Basically answer would have been 59.96. That was a very, very bad mistake from my side. That was 45.71. So this answer was 45.71. Here also you would get the 45.71 as well. So this was actually the complete method, that you find out E of W before and then you find out E of W square as well, and then you get sigma W square, and this is just the formula. Okay, so two methods are there. Whatever you want to use, you can use it. Next, find the correlation coefficient of random variable x and y. Correlation coefficient. What we need to find? Correlation coefficient. Correlation coefficient of random variable x and y. That was given as sigma xy divided by sigma x into sigma y. So sigma xy, are you already having? Sigma xy, are we already having? No, we are not having sigma xy, right? Yeah, so we are having, no? Covariance. This is your sigma xy, no, covariance. So minus 1 by 2 under root 3 divided by. Are you having sigma x? Yes, sigma x is under root 9 by 4. What is sigma? Sigma x square is 9 by 4. So sigma x would be under root 9 by 4. That means you can write it down as 3 by 2. Basically, sigma x square is 9 by 4. So sigma x would be under root of 9, that is 3, under root of 4 will be 2. And what would be your sigma y square is given as 11 by 2. Sigma y is equals to under root 11 by 2. So you can solve it whatever the answer you get. So this was your correlation coefficient, sigma xy upon sigma x dot sigma y. So sigma xy was already there, sigma x was already there, sigma y was already there. So this question was just purely based on the formula. Whatever the formula that we have studied, we just revise over the formula, nothing else, right? So purely it was formula based. Well and good. Let's move to the next. So there is an important note. In the statement, what could be written? That random variable x and y are orthogonal. So if your random variable x and y are orthogonal, what is the meaning of that? That your exy would be equals to 0. Orthogonal random variable. That means your correlation will be equals to 0. Correlation will be equals to 0. So what about your covariance? So covariance is given by exy minus exey, right? This is how your covariance is given. Now this is equals to 0. So your covariance would be coming out to be minus mu x mu y. So first could be mentioned orthogonal, that your random variable x and y are orthogonal. So how would you remember that E of xy is equals to 0? Whenever they talk about orthogonal in whole electronics, they talk about 0. Do you remember orthogonal signal? xt, x1t dot x2t conjugate u integrate dot dt is equals to 0. Then your x1t and x2t are called orthogonal, right? So whenever you talk about orthogonal, you talk about 0. Do you remember orthogonal vectors, orthogonal matrix? There as well you talk about 0 only. Orthogonal matrix means there also you multiply two matrix equated to 0, right? So here also orthogonality means simply means something should be equated to 0. So x and y are orthogonal random variables. That means E of xy should be equal to 0. If you remember E of xy is equal to 0, then you can write down everything, right? Uncorrelated. If it is given that x and y are uncorrelated random variable, that means expectation of xy, E of xy would be equals to E of x dot E of y. Okay, basically you can separate them. Is that okay for you? Expectation of xy would be equals to expectation of x dot expectation of y, right? So you can say that my rxy, this is my rxy, right? It would be coming out to be mu x mu y. And what was your cxy? Your cxy was equivalent to E of xy minus E of x E of y. So what they are saying, uncorrelated, but here correlation is not equals to 0, covariance is equals to 0. Are you able to understand this point? What they are saying, that they are uncorrelated, but still your covariance is equals to 0. Your sigma xy is equals to 0. Your correlation is not equals to 0. It feels like that, sir, correlated. Correlated means correlation, but no, it has nothing to do with the correlation. It has something to do with the covariance. That's why I said that covariance is the boss. Here I said, who is the boss? Covariance is the boss. So whatever we will be talking about, mostly we will be focused towards covariance. So don't remember anything. Just remember this particular thing and this particular thing. That's it. Only these two things you need to remember. Are you able to understand this point? X and y are orthogonal. E of xy is equals to 0. X and y are uncorrelated. That means E of xy is equals to E of x dot E of y. X and y are independent. So x and y are independent means any function of x and any function of y, and you take their expectation, that would be equivalent to expectation of gx capital X, any function of random variable x dot expectation of not having enough space, uncorrelated, independent, expectation of any function of random variable x, any function of random variable y would be equals to expectation of random variable x into expectation of random variable y. Basically here any function could be there. Basically what does that mean? 2x plus 3 into y square plus 2. So this will be equals to expectation of 2x plus 3 multiply with expectation of y square plus 2. If your x and y are independent random variable, if your x and y are uncorrelated, then only this relation is true. This relation is not true for uncorrelated. So this is the difference between uncorrelated and independent. Okay. So here strictly random variable x is written. Strictly random variable x is written. Here strictly random variable y is written. But here any function of random variable x, any function of random variable y. Okay. Is that okay for you? Right. And another thing you already know that if your x and y are independent random variable, then this particular thing is also true. So basically whatever uncorrelated is having, independent is already having that. But whatever independent is having, uncorrelated is not having. Are you able to understand what I am saying? Whatever independent is having, uncorrelated is not having. But whatever uncorrelated is having, independent is surely having. Right? So these two things are there for independent random variable. So let's see the again major difference between independent and uncorrelated random variable. So if I am saying that x and y are independent random variable, that means any function of random variable x and any function of random variable y, if you are calculating their expectation, so that would be equivalent to expectation of gx, expectation of hy. Okay, basically expectation of x square plus 3 dot expectation of y square plus 2y plus 4. But for uncorrelated only x and y should be there. That means expectation of xy would be equals to expectation of x dot expectation of y. And if this is the scenario, then surely your covariance will also be equals to 0. So don't care much about correlation. Okay, we will not care about much of correlation, but we will care about correlation at all. Okay, we will care about covariance. Okay, not correlation, we will care about covariance. So covariance is 0 here, which you can write down from here very easily. But here you cannot say that if x and y are uncorrelated, that means you cannot say that this would be surely equal. No, you cannot say. Okay, you cannot comment much about this. So here not equals to sign, but here equals to sign. This is the difference. And if x and y are independent, then they are surely uncorrelated. But if x and y are uncorrelated, then they may or may not be independent. Is that okay for you? All good. So statements in the line, there could be written that x and y are independent random variable. So you should know this particular thing and this particular thing. X and y are uncorrelated. Uncorrelated means cxy is equals to 0. Uncorrelated. Okay. Expectation of xy is equals to expectation of x dot expectation of y. Now what is the meaning of covariance? Covariance means expectation of xy minus expectation of x dot expectation of y. So that means they are equal. So c of xy covariance is equals to 0. Okay. And orthogonal means, what is the meaning of orthogonal? Orthogonal means expectation of xy is equals to 0. All good, all fine. So let's see this question. fxy is given, xy divided by 9. You need to find the covariance of random variable x and y. Then you need to check independency, orthogonality and uncorrelation. Basically they are they are correlated or not. They are uncorrelated or they are correlated. Basically this particular thing and this particular thing you need to check. So first thing is you need to find the covariance of random variable x and y. What you need to find? Covariance of random variable x and y. So that would be equivalent to expectation of xy minus expectation of x dot expectation of y. This is what you need to find, right? Covariance. That means you need to find expectation of xy as well, you need to find expectation of x as well, and you need to find expectation of y as well. How will you find expectation of xy? Whatever the region it will enclose, in this region what you will do, xy fxy xy dot dx dy, right? How will you find expectation of x? So whatever the limit of x is there, whatever the limit of x is there, x dot fx of x dot dx. And how will you find expectation of y? Whatever the limit of y is there, y dot fy of y dot dy. You would require fy of y, you would require fx of x. Marginal PDF of random variable x, marginal PDF of random variable y. So you know that how to find this one, you know how to find this one, then you can integrate. You are already having this particular thing and you know how to integrate over a surface as well. So do this thing on your own. Do everything on your own. I will pause the video, take a break. You should be able to do this particular question. Now everything we have studied in the last lecture. That's why I spent 3 hours there. Every particular surface I was taking, I was telling you this particular formula you can use, like this is how you can integrate. So we have spent 3 hours in the last lecture only for this purpose. Now this lecture will be very easy for you. Otherwise things would have become very complex. So do it on your own. Okay, I will pause the video, you do it on your own. Yeah, welcome back. So let's do this question. Here random variable x is taking value between 0 to 2 and y is taking value between 0 to 3. So random variable x is taking value between 0 to 2. I told you whenever there is a question based on 2-dimensional random variable, the first task would be always you make the region of working. So region of working would be random variable x taking y taking value between 0 to 3 and x taking value between 0 to 2, right? So this will be our region of working. Here we need to talk about everything, right? So I can take the strip or whatever I want to take, there I will take here, right? So eventually to solve this problem I need to find fx of x and fy of y as well. So how will I find fx of x? So you remember one thing, that fx of x will be a function of x. That means what I will take, I am having my fxy, but I will integrate with respect to y. If you are integrating with respect to y, that means you will take the horizontal, or I would say not horizontal, vertical strip. So limit of y is going from y equals to 0 to y equals to 3. Y equals to 0 to y equals to 3. So what is given? X by y 9. dy y equals to 0 to 3. So what you are getting? X by 9 outside, y square by 2, 0 to 3. So it is coming out to be x by 2. So your fx of x is coming out to be x by 2 for the limit of x going from 0 to 2, right? Limit of x is actually going from 0 to 2 only, no? For the limit of x going from 0 to 2, this is your fx of x. And if I need to calculate fy of y, what that would be? X going from, what I will do, I will take the horizontal strip, right? So I will take the horizontal strip, and in this horizontal strip, what do I see? For value of y going from 0 to 3, x is going from 0 to 2. X is going from 0 to 2. I don't need to write it down. This is very pretty obvious, right? Very obvious. And here also the same thing, xy by 9, but dot dx, right? So y by 9 will come outside, x square by 2, 0 to 2, so 2y by 9. So this is your fy of y. You are getting fy of y as 2y by 9 with values of y going from 0 to 3. There you go. So two things you have got, fx of x, fy of y. Here only you can see one thing, that your fxy x comma y is equals to fx of x, fy of y. If you multiply both of them, what you are getting? X by 2 into 2y by 9. What you will get? Xy by 9. And that is equals to fxy only. So from here only your job is done. Which kind of job is done? From here only you can say that x and y are independent. X and y are independent. And if they are independent, that means surely they will be uncorrelated as well. What did I say? If x and y are independent, then surely they will be uncorrelated as well. Without even finding all these things, I just said that x and y are independent. Along with that, I can say that x and y are uncorrelated as well. Y are uncorrelated as well. Right? Next, I need to care about what I need to care about. I need to care about expectation. I need to care about orthogonality now. Right? I need to care about orthogonality. So from here, what I need to find? Expectation of xy. Because if your expectation of xy is coming out to be 0, if your expectation of xy is coming out to be 0, then you can say that it is orthogonal, right? X is going, you can take any strip, x will go from 0 to 2, y will go from 0 to 3. Very simple. X will go from 0 to 2, y will go from 0 to 3. And directly you can see here is that it will surely not come out to be 0, right? Or you can see xy. What is the value of fxy? Value of fxy is xy by 9. Value of fxy is xy by 9. Dot dx dy. Limit of x going from 0 to 2, limit of y going from 0 to 3. 1 by 9. This is x square, right? So x cube by 3 going from 0 to 2. Then y cube by 3 going from 0 to 3. So 1 by 9 into 8 by 3 into 9. So what is the answer you are getting? 8 by 3. Expectation of xy is coming out to be 8 by 3. Simple integration you can solve it. X cube by 3, y, here you will get y square. So y cube by 3, 1 by 9 was constant. Then 8 by 3, here you will get 27 by 3, which is equals to 9 only. So 8 by 3 is the answer, right? And if I ask you expectation of x, so what that would be equals to? X is going from, what is the limit of x? X is going from 0 to 2. X is going from 0 to 2. X fx of x dot dx. So 0 to 2. What is your fx of x? Your fx of x is x by 2. So what you will get? X square by 2 dot dx. So here you will be getting x cube by 3. So it would be 6 from 0 to 2. What is the answer you are getting? 8 by 6. Right? And what will be your expectation of y? Y is going from 0 to 3. Right? Y is going from 0 to 3. And what is the function of fi of y? Function of fi of y is 2y by 9. So it is 2y square by 9. dy, what you will be getting? 2y cube divided by 27, 0 to 3. So what is the answer you are getting? 2. So what you can see directly here, expectation of xy is coming out to be 8 by 3, which is not equals to 0. Along with that, expectation of x is 8 by 6 and expectation of y is 2. If you multiply both of them, expectation of xy is actually coming out to be expectation of x dot expectation of y, which was pretty expected as well, because here only I said that they are uncorrelated. So yes, so what did you understand? They are independent, they are uncorrelated, but they are not orthogonal. There you go, your job is done. This question is also done. Okay, let's solve the next one. You need to find the variance of random variable z. So all three conditions are given. So first let's find the variance of random variable z. What that would be? Variance of random variable z would be equals to 9 into random variable, variance of random variable x, 16 into variance of random variable y plus 2ab. So 4 into 3, 12, 12 into 2, 24. 24 and then covariance, right? 9 sigma x square plus 16 sigma y square minus plus 2ab actually, but this is a negative sign, so minus 24 cxy. Now x and y are uncorrelated. This is the answer. This is the answer. But let's check the first condition. X and y are uncorrelated. Uncorrelated. X and y are uncorrelated. So what you will think? X and y are uncorrelated. So what you will think? Okay, x and y are uncorrelated. That means this particular thing is there. Right? This particular thing is there. Now, what do you think? What will be the value of cxy now? So sir, cxy is given as exy minus exey. I am just telling that in the exam how will I solve it. Otherwise I would have directly said that uncorrelated means covariance should be equal to 0. So this is your covariance, that should be equal to 0. But how will you think? Uncorrelated, that means expectation of xy is equal to expectation of x dot expectation of y. That means both are equal, so cxy is equal to 0. So answer for the first one would be sigma z square would be equal to 9 into sigma x square plus 16 sigma y square. That's it. For the second one, if x and y are orthogonal, okay, you will think orthogonal. Orthogonal means surely it has something to do with 0. So what will be my cxy equivalent to? Here you will put 0, so that would be equal to minus mu x mu y. If I put exy equals to 0, so 0 minus expectation of x into expectation of y. So expectation of x I am putting as mu x, expectation of y I am putting as mu y. So what will be the answer I will be getting? Sigma z square would be equals to 9 sigma x square plus 16 sigma y square, and here in place of cxy what I will put? Minus mu x mu y. So what answer I will be getting? 24 mu x mu y. 24 mu x mu y. So whatever the condition is given, based on that you can get your answer. And what about the third one? So third one and option A and option C will be same only. Because if x and y are uncorrelated, then this is the condition. If x and y are independent, then also this will be the condition. No? At least minimum condition this will be there. If x and y are independent, then this condition will be there, no, for sure. Because for independent, what did we write? For independent, any function of x and y could be there. So g of x could be equal to x, h of y could be equal to y. So at least this condition would be there for sure. So in the independent as well, this answer would be the same. Okay. So A and C will have the same answer. This is the answer of B. Well and good, very simple. Let's move to the next one. X can take, now this time x is your discrete random variable. X is a discrete random variable which can take value -1, 0 and 1. Probability of x taking value -1, 0 and 1 are same, that is equal to 1 by 3. Y is equal to x square. You need to find expectation of x, expectation of y and expectation of xy, and then you need to comment on all these things. Okay. So first what I need to find? Expectation of x. So what I will do? I will take x and multiply with its I will take x and multiply with the probability of it. So I will take the value of x, I will multiply with the probability. I will take the value of x, I will multiply with the probability. I will take the value of x, I will multiply with the probability. What is the expectation of x? 0. Now I am not having the PDF of y, no, or PMF of y. Here it is discrete random variable, so we will talk about PMF. So expectation of y I need to calculate. So sir, I am not having the PMF of y. So why do you need to calculate the PMF of y? X and y are interrelated, no? So basically you need to calculate expectation of x square, nothing else. Are you able to understand this point? So what you will do? You will do the x square. You will do the x square and will multiply with its probability. You will do the x square and you will multiply with its probability. You will do the x square. You will do the x square and then multiply with its probability. What is the answer you will be getting? 1 by 3. This will be 1 into 1 by 3. This will be 1 into 1 by 3. Answer would be 2 by 3. Next I need to find expectation of xy. So what do you think what I will do? X and y are having some relation, no? So x cube. In place of y I need to put x square. So x into x square will be x cube. So what I will do? You will do the cube of x and then multiply with its probability. You will do the cube of x and multiply with its probability. You will do the cube of x and multiply with its probability. So what you will be getting? minus 1 by 3 plus 1 by 3 again 0. So what do you see here? Expectation of xy is coming out to be expectation of x dot expectation of y. Along with that, expectation of xy is also coming out to be 0. Expectation of xy is coming out to be 0, that means orthogonality is done. Expectation of xy is coming out to be expectation of x dot expectation of y. That means uncorrelation is also done. They are uncorrelated. Are you able to understand this point? From here, uncorrelation, right? And from here, you can say orthogonality. What about independency? So, sir, for independency, sir, I need to check something. What I need to check? Sir, I need to check the PMF. Basically, if they are independent, so I will have to check the PMF. That PMF of xy should be coming out to be as PMF of x multiply with PMF of y. This is what I need to check, sir. This is what we are thinking. Yeah, ideally you should check, but think about it, no. X is already depending on y and y is already depending on x. Directly you can see here, no, that x is depending on y and y is depending on x. Are you able to understand this point? X and y are related with each other. Sorry, x and y are depending on each other, no. Like if x is taking value -1, then y has to take value 1 only. Are you able to understand this point? If x is taking value -1, y has to take value 1 only. Y cannot take any other value. So value of y is depending on x. And if value of y is 1, then x can take either value -1 or it can take value 1. So if y is fixed, then x is also fixed. That means x can take only 2 values. So x and y are depending on each other, no? So they are not independent. Okay? X and y are depending on each other. Depending on each other. That's the bottom line. Well and good. Okay. Let's go to the next question. So this is a very simple question. If fx of x is equals to fx of minus x, then you find the expectation of x. What does that mean? That fx of x is equals to fx of minus x. That means PDF of random variable x is even. PDF of random variable x, random variable capital X is even. Say yes or no. Fx of x is equals to fx of minus x. That means PDF of random variable x is even. This is the meaning, right? So you need to find the expectation of x. So what will be your expectation of x? Minus infinity to infinity x fx of x dot dx. What is this? Even. And what is this? Basically, if I say my gx is equals to x, so this graph is even or odd? G of minus x will be equals to minus x. That means it is equals to minus gx. That means this is your odd. This is odd. And do you remember odd multiply with even? Odd multiply with even. What that would be? Odd only. So this whole function, if I say that my h of x is x fx of x. Okay, my h of x is x fx of x. So what this kind of function is there? Now I am saying that also given that fx of x is equals to fx of minus x. So what you will do, if I calculate h of minus x, what that would be? Minus x fx of minus x. Now I know that fx of minus x is equals to fx of x. So this is your h of minus x. So h of minus x is equals to minus x fx of x. What does that mean? This is coming out to be minus h of minus x is coming out to be minus of hx. What does that mean? That means this h of x is odd. Very simple thing, no? This will be odd only. Only thing I need to prove that this will be odd. And if this is odd, that means the whole integration will be equals to 0. So if your PDF is even, then your expectation of random variable x will be 0. For an even PDF, if your PDF of random variable x is even, then its expectation will be equals to 0. This is what I am concluding. If your PDF is even, then your expectation will be equals to 0. All good? All fine? Now this thing is given. You need to comment on orthogonality, independency and uncorrelation. fxy is given. The complex expression is there. Can you make the region of working? Surely I can make the region of working. Comment on orthogonality, independency and uncorrelation. So all the things which we have already seen. So what I need to make? First I need to make the region of operation. Region of working or region of operation, whatever you say. So x square plus y square should be less than 1. What do you think what I will do? X square plus y square should be less than 1. So first I will make the graph of x square plus y square is equals to 1. What is this? This is a circle, right? I hope you know this is a circle. So this is a circle. X square plus y square is equals to 1. But what they are saying, x square plus y square should be less than 1. That means this particular region will come. Basically what they are saying, x square plus y square should be less than equals to 1. So if you put x equals to 0, y equals to 0, what you will get? 0 plus 0 should be less than 1. 0 is less than equals to 1. Is it satisfying? Yes. That means this particular region will come into action. Okay. This particular region will come into action. So what I need to check? Orthogonality. So what I need to find? Expectation of xy. This I need to find. Dx dy. Also I will have to find uncorrelation. For that I would have to find expectation of x as well, expectation of y as well. So that we will see later on. But as of now, let's find out expectation of xy. So what you need to do? You need to choose a strip. What you will do? You will have to choose a strip here. Right? This is the region of operation. So in this manner, this question will become difficult actually, right? If you choose the strip, so from where to where y will go? So y will go from minus under root 1 minus x square to under root 1 minus x square. And x will go from, what this point will be there? X equals to minus 1, 0, x equals to 1, 0. So x will go from minus 1 to plus 1 and y will go from minus 1 under root 1 minus x square to under root 1 minus x square. And then you will have to solve the integration. The integration will become difficult. Yeah, sorry for the interruption. So what I was saying that you can solve this surface integration, but the calculation will be a bit on tougher side, right? So what we will do? So we will use the concept of our EMFT. In EMFT, do you remember the cylindrical coordinate system? What do? We work in the rho direction and then we work for theta, or actually we use the term phi. So first we work for rho and then we go for phi and then we go for z and then we get our full cylinder, right? Similar thing we are going to do here because the integration is tough, no? So what we will do? What I will do is that I will make this circle, but now the circle will not be made with respect to x and y. The circle will be made with respect to our r and theta. So what I will do? I will, from the center I will work for r. From the center I will work for r and then I will move for the theta angle. This is my x, this is my y. Right? Actually this should not be y. This should be y actually. This should be y. So I will work in the direction of r and then I will work in the direction of theta. I will get the complete circle. Basically I need to cover this particular region, no? I need to cover this particular region. So I will work in r and I will work in theta. So those who have studied EMFT, they will be able to relate it. So x will be replaced with r cos theta, right? From here you can see that x is r cos theta and y will be replaced with r sin theta. And what will be your dx dy? So dx dy will be equivalent to r dr d theta. Do you remember all these things? Say yes or no. Right? So this is how we replace all these things. And now I need to solve this integration. Expectation of xy was equivalent to what? In the region R, xy, fxy, x comma y, dx dy. So in the region R, xy, what is your fxy? 6 by pi into 6 by pi x square plus y square dx dy. But now what I will do is that x is equals to r cos theta, y is equals to r sin theta. So what you will get? R square cos theta sin theta. Then 6 by pi is a constant value. X square plus y square will be equals to r square. And in place of dx dy, what you will put? R dr d theta. There you go. Are you able to understand all these lines? What I did was, here I took that, I saw that the limit will be difficult, integration will be difficult to solve. A lot of under root and all these kind of things will come. So what I did, I replaced my x and y with r cos theta, r sin theta. So now I am getting this particular expression. Here the limit of x and y would be there, but now the integration you are doing with respect to r and theta. So what you can see is that your theta will be going from 0 to 2 pi. The limit of theta will be going from 0 to 2 pi. You starting from here 0 to 2 pi, complete path you will move. And from where to where your r will go? R will go from 0 to 1. What is the radius here? Radius is 1. What is the radius of the circle? That is 1. So R will go from 0 to 1. So 0 to 1 and theta is going from 0 to 2 pi. So complete disk you will be covering. Basically this is the disk, no? It is like a disk. So this is what you need to do. R goes from 0 to 1. You are in the direction of R you are working from 0 to 1, 0 to 1, 0 to 1, and in the direction of theta you are working from 0 to 2 pi. So here in the direction of r I am going from 0 to 1. In the direction of theta I am going from 0 to 2 pi. There you go. So what you will do? R square is there. R to the power 5 would be there. Total r to the power 5 dot dr. And here it would be 6 by pi. Right? And limit of r is going from 0 to 1. And here cos theta sin theta. If I multiply and divide by 2, what I will get? 2 cos theta sin theta divided by 2 into d theta. So what is this 2 cos theta sin theta equivalent to? That is equivalent to sin 2 theta. So it is sin 2 theta divided by 2 d theta. And limit of theta is going from 0 to 2 pi. You can solve this integration on your own. This integration will come out to be 0. And you can see that sin 2 theta is having a period of pi. So in 2 pi there will be 2 cycles. So this integration you can solve on your own and this will come out to be 0. So total answer is coming out to be 0. So expectation of xy is coming out to be 0. What does that mean? X and y are orthogonal to each other. Right? X and y are orthogonal. So first thing is done, that is orthogonality. Say yes or no. Very simple thing. If you are comfortable with the EMFT first chapter, or if you are comfortable with mathematics as well, in the mathematics as well we study these kind of things. Whenever you are having the center at origin, then x you can assume as r cos theta, y you can assume as r sin theta, and dx dy would be r dr d theta. And from there you can get all these things. Okay, x you replace with r cos theta, then by replacing this, basically doing all this calculation you are getting answer 0. Even if you are not comfortable with that, so once you study those chapters you will be comfortable, no need to worry. So expectation of xy is coming out to be 0. Well and good. So x and y are orthogonal. Orthogonality is checked. We need to check independency and uncorrelation. So for checking uncorrelation, or if they are uncorrelated or not, so you would require expectation of x, right? You would require expectation of x. And how will you do this? X into fx of x dot dx. And here you will put the limit of x. How your limit of x is going? So x will be going, you will take the horizontal strip, and from there you can calculate it. But before that, all these things, secondary part. What is the major part? Major part is, first I need to calculate fx of x, no? First, this is the major part, no? First you calculate fx of x, then you go here. So first calculate fx of x. So how will you calculate fx of x? fxy x comma y dy, and you will put the limit of y here. What is the limit of y? Y is going from minus under root 1 minus x square to under root 1 minus x square, minus under root 1 minus x square to under root 1 minus x square, right? So your fxy is 6 by pi x square plus y square. 6 by pi will come outside, x square plus y square dot dy, and limit is going from right. So 6 by pi x square, basically what I need to do, 6 by pi whatever the limit is there, x square dot dy plus y square dot dy, whatever the limit is there, this limit you can put. So what you are getting, 6 by pi x square is outside and then dy. So this is 2 under root 1 minus x square, right, plus y cube by 3. Basically this will be 0 only, right? Why it will be 0? No, why it will be 0? It will not be 0. Sorry guys, it will not be 0, right? So whatever the answer you are getting, but from this answer you will understand something pretty good. Under root, this is your x, right? Under root 1 minus x square plus 1 by 3 is outside, 1 minus x square to the power 3 by 2 minus, and this will become plus 1 minus x square to the power 3 by 2. So this will become 2 times. You can solve the integration. This is what you will be getting, right? And what is the constant? This is your fx of x. This is what you are getting as fx of x with the limit of x. Like basically if your y is going from minus under root 1 minus x square to under root 1 minus x square, then x is going from minus 1 to 1. So with the limit that x is going from minus 1 to 1, this is your fx of x you are getting. Say yes or no. This is the fx of x. Just understand one thing here. What do you understand here? In this limit, in this particular limit, your fx of x is even. What you are saying, when your x is between minus 1 to 1, at that time your fx of x is even, and if it is even, then its expectation will be equal to 0. There you go. Here we proved it, no, that if your fx of x is equal to fx of minus x, that means your expectation of x will be equal to 0. But in the limit, you need to see the limit as well, from minus 1 to 1. That means limit is symmetric, my graph is also symmetric. Let's just say whatever the graph we are getting, whatever the graph that I get between 0 to 1, the same graph I am getting between 0 to minus 1 as well. Let's just say only this graph was there, the limit was between 0 to 1. Even though this graph could be symmetric, but random variable x was taking value from 0 to 1 only. So you cannot say that expectation of x will be 0. Are you able to understand this point? It should be even. Just by looking at the expression, let's just say I wrote down e to the power minus x square and I am putting the limit of x from 0 to 1. Will you say that it is symmetric? Although it feels like that, sir, in place of x, if I put minus x, it will be symmetric. But symmetric around what? It should be symmetric around origin, no? So before origin, it is not even there. After origin, it is giving you some expression. That I don't care. But it should be symmetric about origin. So limit of x is going from minus 1 to 1. In this minus 1 to 1, it is symmetric. And if it is symmetric, that means its expectation is 0. The ditto same analysis you can do for the y as well. The same analysis, exactly the same analysis you will do. You need to find fy of y. Then what you will do? You will put the limit of x. How will you put the limit of x? In this direction, you will put the limit of x. So what will be the limit of x would be coming? The limit of x would be coming would be under root 1 minus y square to under root 1 minus y square. Exactly the same expression will come. Ditto same expression will come. Okay. So just let me write down the expression of fy of y. So fy of y will have just the same expression. What you will get? 6 by pi. 6 by pi, because everything is symmetric here, no? 6 by pi y square into 2 under root 1 minus y square plus 2 by 3 1 minus y square 3 by 2, going from minus 1 to 1. So here as well, what you can see, this is the expression, and from here also you would see that in the range of y going from minus 1 to 1, fy of y is equals to fy of minus y, and from here you will see that expectation of y is equals to 0. So what did you see here? Expectation of xy is equals to 0 is equals to expectation of x is equals to expectation of y. Along with that, expectation of xy is equals to expectation of x dot expectation of y. So from here what you are getting, that orthogonality is also there and uncorrelation is also there. So orthogonal and uncorrelated, both done. What about independence? Think about it and let me know. You see the expression of fxy, x comma y. What about independence? X and y are independent random variable or not? Look sir, you will say that sir, I need to multiply fx of x and then I need to multiply fy of y. If I multiply both of them, clearly it is visible that it will not come out to be equals to fxy x comma y. Basically, if you multiply this particular thing with this particular thing, will it come out to be equals to this particular thing? Absolutely not. So directly from here you can say that sir, if I go by the mathematics, this is by the mathematics, that sir, these are not equal. That means not independent. But just once think about it, without even doing the calculation you can tell that it will be independent. Without even doing the calculation, it will not be independent, sorry. Without even doing the calculation you can say that x and y will not be independent. They are depending on each other, no? Basically what you are saying, that x square plus y square should be less than 1. That means x and y will be taking the value such that x square plus y square should be less than 1. What I mean to say is that random variable x and y will be taking values such that x square plus y square should remain less than equals to 1. That means if I say that my x is 1 by 2, then your y has to be under root 3 by 2. Oh sorry, less than under root 3 by 2. Basically if x is 1 by 2, then y is equals to 0. This will work. But y should be less than under root 3 by 2, no? So value of y is depending on the value of x. So x and y are surely depending on each other. If they are depending on each other, that means x and y are not not independent, are depending on each other. That means they are not independent. There you. So if only independency is asked, do you have to do the calculation? No. If you use your brain smartly, only about independency, uncorrelation, orthogonality, you will have to do the calculation of exy, ex, ey. All these calculation you will have to do. But only independency is asked. If only independency is asked, you can use your brain and then you can say that, sir, x and y are depending on each other, so they will not be independent. Right? So we have seen this case that orthogonality is there, uncorrelation is there, but independency is not there. Although your expectation of xy is equals to expectation of x dot expectation of y, but independency is much more than that. Independency will say that along with expectation of xy is equals to expectation of x dot expectation of y, I will be expecting this thing as well. If this thing is done, then my job is done. If this particular thing was there, then it was independent as well. Along with that, it would have been uncorrelated as well. But if this thing is not there, then it cannot be independent. And without even doing the calculation, by using our brain, I could see that x and y are depending on each other, so they can never be independent. Now in this question, I am only asking one thing, that x and y are independent or not. So just think about it, no? X and y are depending on each other. If you make this graph, what kind of graph you will be getting? If you make this region, what kind of region you will be getting? X is greater than 0 but less than y. X is greater than 0 but less than y. So x less than y, that means y is larger. Y is larger. Greater than 0 but y is larger. This is the region. And what about y? Y is less than 1. Y is less than 1. So till this point you should be comfortable in making all this region. So y is less than 1. So x will be between 0 to 1. Basically this will be the region of operation. And this is your y equals to 1. This point will be 1 comma 1. So this will be the region of operation, region of working. So this region you can make on your own, and directly you can see here is that x and y are depending on each other. You can see x should be less than equals to y. So if, let's just say if y is 0.5, then x has to be less than 0.5. So value of x is depending on y. That means they are not independent. That's it. So you are not going to find fx of x. You are not going to find fy of y. Then you will say, sir, fx of xy is equals to fx of x dot fx of y. This thing you are not going to do. Just by looking at the expression, you can say that they are not independent. There you go. Okay, well and good. Now solve this question. Only mathematics, purely mathematics it is. Just you need to apply the formula and you will get the answer. X and y are two random variable. Expectation of x is given. Sigma x square is given. Sigma y square is given. What is this? Correlation coefficient. This is your correlation coefficient. What you need to find? You need to find correlation and covariance. So this is your correlation coefficient is given, which is equals to sigma xy divided by sigma x, sigma y, right? So what is your sigma x? Sigma x is under root 6. And what is your sigma y? Sigma y is 3. So what would be your sigma xy? That would be minus 2 by 3 into sigma x will be under root 3 and under root 6 into 3. So answer would be minus 2 under root 6. So this is your sigma xy. This is the answer. Very, very straightforward. Nothing is there. And what next I need to find? Covariance. Sorry, correlation. Correlation I need to find, which is E of xy I need to find. Right? So you know that if I know sigma xy, that is equals to rxy minus mu x mu y. If you don't remember the expression, you remember the expression of E of xy. Basically, usually we remember this expression, E of xy minus E of x into E of y. So from here, what is rxy is coming out to be? Sigma xy, what is sigma xy? Minus 2 under root 6 plus 2. There you go. This is the answer. Basically, this goes here. So this will become plus, and then 2 into 1. Mu x into mu y is 2. Mu x into mu y is 2 into 1. That would be 2. And this goes here. So exy or rxy, whatever you call it. Expectation of xy or rxy you can call it is equals to minus 2 under root 6 plus 2. And here it was very simple. Correlation coefficient was given. That is minus 2 by 3. And that is equivalent to sigma xy. That is equals to covariance divided by sigma x into sigma y. Sigma x is under root 6, sigma y is 3. So 3 into under root 6. So answer is minus 2 under root 6. This is the answer. Well and good. Okay. Now, which of the statement is true? If x and y are orthogonal. So they are talking about orthogonal and uncorrelation. So let's write down the condition. Orthogonal. Orthogonal. If orthogonal means expectation of xy would be equals to 0. So what would be your sigma xy? Sigma xy would be 0 minus mu x mu y. That would be equals to minus mu x mu y. Right? And if this is 0, that means rxy would be equals to 0. So rxy is 0 and this is 0. Right? And what about uncorrelation? Uncorrelation means expectation of xy is equals to expectation of x dot expectation of y. Right? What is this expectation of xy? This is your rxy is equals to mu x mu y. If uncorrelation is there, then this particular thing is true. Along with that, this was given as rxy minus mu x mu y. So if both are equal, this would be equals to 0. Very simple thing. This should be done on your own. If you are not able to solve this problem, that means you are not putting your concentration in the class. You need to put the concentration to solve this kind of problem. Very simple it is. Just remember the condition. Orthogonal, expectation of xy is equals to 0. Uncorrelation, expectation of xy is equals to expectation of x dot expectation of y. That's it. Job done, right? So yeah, this is the end of this lecture. But now we are going to see some mathematics. Basically, our statistical parameter has ended. We have studied about mean square value, variance, movement about origin, joint movement about origin, then movement about mean, joint movement about mean, correlation, covariance, and correlation coefficient. So all these statistical parameter we have seen, right? So this chapter has ended now. But in the next chapter, what we are going to study? We are going to study some standard PDF. There we will see Gaussian PDF, we will see our uniform PDF, and some other kind of PDF also we will see, right? So for that, what we are doing? For that, we are studying some basic mathematics, some basic mathematical points we are going to see here. That will help us to understand the next lecture. So for the next lecture, we are building up our concept now. Is that clear to you? So first, let me answer this. First, you answer this particular question. If f of t dot dt is having an area of a, basically, if I solve this particular integration and my answer is a, then what will be the answer if I solve this particular integration? That will be a into a. Say yes or no. If I solve this particular integration, my answer is a. If I solve this particular integration, my answer will be a into a. Say yes or no. Basically, you can put t by a is equals to alpha. So dt would be equals to d alpha by a. Oh, sorry, dt will be equals to ad alpha. Ad alpha. Then you can put minus infinity, because if t is minus infinity, then alpha is also minus infinity. If t is infinity, then alpha is also infinity. F of alpha, and in place of dt you need to put d alpha. A goes here. So what is this? This is equals to capital A only. So what is the answer? A into A. So yes, answer is A into A only. So this thing you should be knowing. Now if you have studied signal system, you will be able to tell me what will be the answer of this area. E to the power minus x square dot dx. What is the answer? Under root pi. Say yes or no. Do you remember? If you don't remember, then from now onwards you will remember it. E to the power minus x square dot dx. If you calculate the whole area from minus infinity to infinity, answer would be pi, under root pi. Okay? Say yes or no. You will be able to remember? E to the power minus x square dot dx. Going from minus infinity to infinity, that would be equals to under root pi. Okay? And how will you remember? Those who have studied signal system in a good manner, they will be able to relate. E to the power minus 80 square. What did I tell you? Under root pi by a, e to the power minus omega square by 4a. You remember this thing? In place of a, if you put 1, e to the power minus omega square by 4 under root pi. And to calculate the area, what you will do? Omega equals to 0. So if you put omega equals to 0, you are getting under root pi by a. But here a is equals to 1. So under root pi. Right? All good? All fine? Now, is this an even function? Yes. If it is an even function, then what you can do? E to the power minus x square dot dx. Right? If it is an even function, so whatever the area you are getting from 0 to infinity, the same area you will be getting from minus infinity to 0 as well. Right? Whatever the area you are getting from 0 to infinity, the same area you will be getting from minus infinity to 0 as well. So that's why I can break it down like this. So what will be the area I will be getting here? Under root pi by 2. Okay? Under root pi by 2. Because basically this is the half area, nothing else. Now from minus infinity to infinity, e to the power minus x square by 2. What do you think what will be the answer? Under root 2 pi. Why is that so? Because minus infinity to infinity, in place of x, what I am putting? X by under root 2 whole square dot dx. So in place of t, I am putting t by a. In place of x, I am putting x by under root 2. So whatever the previous answer I was getting, I just need to multiply with under root 2. So what is the answer I am getting? Under root 2 pi. So from now onwards, what you will remember, e to the power minus x square divided by whatever that is there, whatever the number is there, that will come in the under root. Like with the practice, you will be able to remember all these things, okay? As of now, only thing that should matter you is this. If you remember this thing, then you will be able to tell this particular thing as well. And if you remember this particular thing, then you will be able to tell this particular thing as well. So e to the power minus x square by 2 dot dx. If I ask you integration from minus infinity to infinity, directly you should be able to tell that sir, this would be the answer. Under root 2 pi would be the answer, without even thinking anything else. Say yes or no. Will you be able to tell the answer? Surely you will be able to tell the answer, right? So yeah, this is the mathematics that I ask you to remember. Now there is something called Q function. It is a kind of function only, okay? So there is something called Q function. Like any kind of function I can define, no? Like modulus function. Modulus function is fx of x mod x. Signum function. Signum function is fx of x signum x. A quadratic function could be ax square plus bx plus c. So in the same manner, there is something called Q function. So this is a function. So this is a function. What is the definition of this function? The definition of this function is 1 upon under root 2 pi e to the power x to infinity e to the power minus x square by 2 dot dx. This is the definition of Q function. 1 by under root 2 pi integration limit x goes from infinity e to the power minus x square by 2 dot dx. I will tell you a way to remember this. Don't worry about it. I will tell you a way to remember as well. But first let me find the value of x of minus infinity. Can you let me know the value of x of minus infinity? Surely you can let me know the value of x of minus infinity. What that would be equivalent to? Put minus infinity e to the power minus x square by 2 dot dx. So 1 by under root 2 pi is outside. What this will throw? E to the power minus x square will throw under root pi. Whatever that is there downward, that will come in the under root. So what you are getting? 1. So x of minus infinity is 1. What do you think? What will be the value of x of 0? For x of 0, 1 by under root 2 pi from 0 to infinity e to the power minus x square by 2 dot dx. 1 by under root 2 pi into e to the power minus x square dot dx. From minus infinity to infinity is giving you under root 2 pi, but the limit is from 0 to infinity now. That means it is half. And why directly half? Because it is a even function. In place of x, if you put minus x, it is a even function, so simply half. So what is the answer you are getting? 1 by 2. And what about q of infinity? So 1 by under root 2 pi q of infinity. So going from infinity to infinity e to the power minus x square by 2 dot dx. You are taking the limit from infinity to infinity. If I go from a to a on a graph, how much area I am covering? 0. That's it. 0. What is the answer? 0. So at minus infinity, you are having the value 1. And then here the value you get 1 by 2. At minus infinity, you are having the value 1. Here you are having the value 1. Then you get 1 by 2. And at infinity, you are getting the value 0. So this is how the graph is going like this. Say yes or no. The graph is kind of going like this, right? From 1 to 0. So this is your Q function. Isn't it just opposite of your CDF, cumulative distribution function? Cumulative distribution function will start from 0 and it will go to 1. And your Q function is starting from 1 and going to 0. So kind of you will remember that it will go from 1 to 0. You will be able to remember the graph, no? At least you will be able to remember the graph from 1 to 0. What is the graph of Q function? Now I am telling you a way to remember that definition. So what you will write down? So only thing you need to remember is that here e to the power minus x square will not come, e to the power minus x square by 2 will come. So e to the power minus x square by 2 will come. Now you will think that, sir, how much area this will throw? This will throw 1 by under root 2 pi area. So this will throw under root 2 pi area, but I will have to divide by under root 2 pi here, because I know that q of minus infinity is equals to 1. So in that manner, in my brain, I will think, okay, q of minus infinity is equals to 1. Now I will be thinking about the limit. So like in a longer run, confusion would be there, sir, minus infinity to x, or sir 0 to x, or sir x to infinity. Sir, what was the limit? I don't remember. But you will remember the graph. Okay, sir, at minus infinity the value was 1. So there is no chance that limit could go from infinity to minus infinity to x. This limit cannot be there. Why is that so? Because if x is equals to minus infinity, then it should throw the value 0. But it is not actually throwing the value 0. It is throwing the value 1. So by your own, you will think, okay, the limit has to go from x to infinity. Like in a longer run, how will you remember that? I am telling. Okay, like my job is done here. I wrote down everything, I explained everything, and my job is done. But as a student, how would I think? How would I remember? That I am telling you. Okay. So Q function, one thing I need to remember, e to the power minus x square by 2 will come. And when we study Gaussian PDF, you will be able to remember this particular thing as well. No need to worry about that. The confusion will be about here what will be the amplitude. Like someone will be saying, sir, it is 1 by 2 under root pi. Or sir, it was under root 2 pi. So what you will think? E to the power minus x square by 2. Okay. So area will be under root 2 pi. So here it was 1 by under root 2 pi. Well and good. Okay. Then e to the power minus x square by 2 dot dx. Now confusion will be about the limit. So how will you think? Okay, sir, I remember the graph of Q function. It is just opposite of CDF. It will go from 1 to 0, 1 to 0, 1 to 0. That means at minus infinity it is 1. So limit has to go from minus infinity to infinity. That means from x to infinity. There you go. So this is how you will be able to define your Q function. In the longer run, this is how I can keep it in my mind. Otherwise, you keep on revising it and you will be able to remember the definition. So only definition that I am asking you to remember is definition of Q function. Okay. Right. Now some things are there which you can keep in your mind. So basically what will happen is that this Q function will be used at a lot of places. So basically in digital communication as well it will come into action, in random variable as well it will come into action, in random process as well it will come into action. So let's just say my answer is coming out to be x q 0.3. This is what my answer is there. Basically q and the value of x could be between minus infinity to infinity. So this is my answer. But in the option something else can also be mentioned, because this is just a function, no? You got your answer q 0.3, which is just a function. It is nothing but just a function. So I can define some other function. Let's just say I define some px function in this manner, that it is going from minus infinity to x, e to the power minus x square by 2 dot dx. This is how I am defining my some other px function. So I can give my answer in terms of px as well, no? This q of x could be converted to p of x as well, just by doing some calculation. We will do this kind of question, but I'm just telling that we will do all the calculation in terms of q function. And 99% chances are there that in the option Q function only will be mentioned. But 1% chances are there that they will define some other function and they will say that you need to give your answer in terms of this P function. Some other function could also be there. F function could be there. So different kind of functions are possible. Are you able to understand this point? Okay. So regarding that particular thing, we are going to see something now. What we are going to see? First thing is that q of x plus q of minus x is always equals to 1. You can think about it. This is the graph of q of x. Can you draw the graph of q of minus x? Yes. This will be the graph of q of minus x. And if you add both of them, what will happen? 1 plus 0 will be 1. Half plus half will be 1. 1 plus 0 will be 1. So q of x plus q of minus x. Q of x plus q of minus x is always equals to 1. So q of minus x will be equals to 1 minus qx. So if your q of x is having some definition, so q of minus x also has some definition. So that definition is something like this. You don't need to remember this definition. Only difference is here it was going from x to infinity. Now it is going from minus infinity to x. And yeah, one more thing. Again here the same thing. Like if I am putting the limit of, if I am differentiating with respect to, if I am integrating with respect to x, and I am putting the limit in terms of x only. So this is not correct, no? So actually I should have put t here. Right? I should have put t here. Why t, you understood, no? The same thing we have already seen. Like if my limit is there in terms of x, then I cannot put x here. No, limit is there already in terms of x. So what I will put? I will put t here. So in place of everything, here I should have put t. Because some people will be having the doubts that, sir, if you are putting x equals to minus infinity here, then here also if you need to put x equals to minus infinity. But no, that is wrong. Here it should be t. Should be t. Should be t. Right? So in the similar manner, q of minus x is also having a definition. Here it was going from x to infinity, it is coming from minus infinity to x. All good? So this is the definition of q of minus x. In the similar manner, there is a function defined complementary error function. There is something called error function and there is something called complementary error function. So what is the relation between error function and complementary error function? So let me write it down again. Basically, how will you remember? Error function plus complementary, error function plus complementary error function. This stands for complementary and this stands for error function. So error function plus complementary error function is also equals to 1. This is what you need to remember. Q of x plus q of minus x is equals to 1. Error function plus complementary error function is equals to 1. Now how these two are interrelated? So these two are interrelated as error function of x is equals to 2q under root 2x. Basically, let's just say you got the answer x of 0.3. But in the examination, what could be mentioned? 1 by 2 ERFC 0.3 by under root 2. You solved a particular question. You solved a question based on digital communication. Your answer was Q 0.3. But actually, what was the option mentioned? This was the option mentioned. So you need to click on this one, no? So you need to convert this to this one. So how will you convert? You will use this formula. So again, the second thing I am asking you to remember is this, that how your q of x and error function of x is interrelated. Will you be able to remember? Surely you will be able to remember. And similarly, if I need to relate this thing with the error function, how will I relate it? 1 by 2 is outside. So error function, complementary error function of x is equals to 1 minus error function of x. So this is how it can be related. Because both addition is equals to 1. Addition of both of them is equals to 1. This is what you can remember. Okay. This is the second thing. This is this thing I ask you to remember, and this also thing I ask you to remember. That's it. You don't need to remember this particular thing, because your answer would be in terms of q of x. You need to convert it into error function. So always 1 by 2 complementary error function x by under root 2 is equals to q of x. So q of x is equals to 1 by 2 error complementary error function of x by under root 2. Okay. So this is what you need to remember. Now in the similar manner that q of minus x is having some definition, so error function of x is also having some definition, which is this. And similarly this is your complementary error function and this is your error function. So similarly your error function is also having some definition. So these guys are also having the definition. This definition is also there, this definition is also there, but you don't need to remember the definition. What you need to remember? Q of x plus q of minus x is equals to 1. Okay. Error function of x plus error function of plus complementary error function is equals to 1. Error function plus complementary error function is equals to 1. How q function and complementary error function are interrelated? So q function is equals to 1 by 2 complementary error function x by under root 2. So q of x is equals to 1 by 2 complementary error function x by under root 2. And how these two will be interrelated, that you can do on your own. So these three boxes that I have put, these you need to remember. That's it. The definition, just for your reference, I have put that error function of x is having this definition. Complementary error function of x is having this definition and error function of x is having this definition. They are having these definition which are not important to remember, but the relation between complementary error function and q function, this you need to remember, and the relation between error function and complementary error function, this you need to remember, and the relation between q of x and q of minus x, this you need to remember. Very easily you will be able to remember these three things. Is this okay for you? Along with that, you need to remember the definition of q function as well. definition of Q function along with the graph as well. Definition and this graph, and surely you will be able to write these values as well. Now why I did all these things? Because of this particular question. Okay, so what I feel is that this year or next year what they can do, because in digital electronics, like from now onwards this Q function will keep on coming. In the digital electronics completely it will keep on coming, this Q function, and usually answer are always mentioned in terms of Q only. But what I feel is that what they will do is that they will mention the answer in terms of P, and they will define the P like this. So what I have done here, that you did some calculation, and your answer came out to be Q of 0.4. But options were mentioned in this manner. And there in the question only they defined P of x like this. Now what is this P of x? I don't have any idea. This is how they have defined your P of x. Your answer came out to be Q of 0.4. But these were the options mentioned. Then you saw what is this P? Then you went to the question and they have defined the P in this manner. Now you need to click on one of the options. Which option you will click on? Think about it and solve it on your own. Pause the video, solve it on your own. Did you understand the question? I solved a particular problem in my examination. My answer came out to be Q of 0.4. But in the options, I saw these options. Okay. Then I saw, sir, what is this P? My answer is coming out to be Q of 0.4. But what are these kind of options? I know 1 by 2 is a value. 1 by under root 2 pi is also a value. What is this P? So for that I looked here. Now I need to click on one of the options. Which option you will click on? Do it on your own. Let me take a break and then I will come back. So do it on your own. Okay. Okay, so let's get started. So what is our answer? Basically our answer is Q of 0.4 that I am having. Now I need to convert it into P of x. So what is the definition of P of x? That is going from 0 to x, they have given e to the power minus t square dot dt. And what is the definition of Q of x? That I already know. That is, sir, 1 by under root 2 pi integration e to the power minus x square by 2 dot dx x to infinity. This is what I already know. Where I need to go, and not x here, I should put t here, right? E to the power minus t square by 2 dt. Now I need to relate both of them, right? So let's start from Q of x and try going towards P of x. This is what I will try. So here I can see that e to the power minus t square is there, but here e to the power minus t square by 2 is there. So what I will do, t by under root 2 I will put equals to alpha. Say yes or no. T by under root 2 I will put equals to alpha. What I will get from here, dt is equals to under root 2 d alpha. Why I am doing so? You will realize 1 by under root 2 pi. Now if your t was x, if your t is equals to x, then alpha is equals to x by under root 2. And if your t was infinity, then alpha is equals to infinity only. E to the power minus. In place of t by under root 2, what you need to put? Alpha. T by under root 2, you need to put alpha. So e to the power minus alpha square dot d alpha dt is equals to under root 2 d alpha, right? Dt is equals to under root 2 d alpha. So this under root 2 comes here. This under root 2 comes here. So what you are getting? Under root 2 will get cancelled out. So under root pi into Q of x is equals to x by under root 2 to infinity e to the power. In place of alpha square, can I put t? Surely you can put t. So this is what I have got. This is not the answer, but kind of I am reaching towards P of x, right? This thing and this thing. I am reaching towards P of x. But now the problem is limit 0 to x, but here you are going from x by under root 2 to infinity. So one thing I can see that x by basically P of x by under root 2. What will be your P of x by under root 2? So that will be from 0 to x by under root 2 e to the power minus t square dot dt. 0 to x by under root 2 e to the power minus t square dot dt, P of x by under root 2. right? And one thing also I know. What do I know? Basically two parts I am dividing. I am trying to relate both of them. So here x by under root 2 is there, so I try to relate by, how did I try to relate? Here I put x by under root 2, or what you could have put here? Under root 2x you could have put here. Basically in place of x you could have put under root 2x. If you don't want to follow this process, now let's follow this process only. Or here you could have done the same thing, but yeah, let's follow this process only. Or we can do another thing as well, that under root pi into x, under root 2x also I could have put. In place of x I could have put under root 2 into x. Then under root 2 will get cancelled out. But this is not I am doing, forget about it. This is something that I am doing. P of x by under root 2 is coming out to be 0 to x by under root 2 e to the power minus t square dot dt. Now I know that from 0 to infinity e to the power minus t square dot dt will throw what? Under root pi divided by 2, right? Under root pi divided by 2. Because from minus infinity to infinity it would have put under root pi. But now the limit is half, so under root pi divided by 2. What this will be equivalent to? From 0 to x by under root 2 e to the power minus t square dot dt plus x by under root 2 to infinity e to the power minus t square dot dt is equals to under root pi by 2. Now you are approaching to the answer. What is this? P of x by under root 2. Why did I break it down like this from x by under root 2? Because x by under root 2, x by under root 2, something I can relate. So P of x by under root 2 plus, what is this? X by under root 2 to infinity e to the power minus t square dot dt. This is your under root pi q of x, and that is equivalent to under root pi by 2. So your answer is in terms of q of x, but you need to represent it in terms of p of x. So you need to get out of q of x will be equivalent to what? So under root pi, divide by under root pi in all the terms. So you will be getting 1 by 2 minus 1 by under root pi p of x by under root 2. There you go. So what was your answer? Q of 0.4 was your answer. So your Q of 0.4 will be equivalent to what? Under root pi p of 0.4 divided by under root 2. There you go. So 1 by 2 minus 1 by under root pi p of 0.4, this is the answer. So what I highly suspect is that this year the question is coming like this. All the time, all the students, everyone, what do they do? We remember all the formula in terms of Q, right? In digital communication, a lot of formula will come. We will remember all the formula in terms of Q. So always our answer will also come in terms of Q only. But what they would do, they will define some another function and they will give the answer in terms of that another function. So you should be knowing that how to relate both of them. So this is how you relate. Whatever the definition you know, you try going towards that particular definition. If that is not working, then try relating both of them, and you would know one thing, that I already know the result of integration, and then I can interrelate the things. So this is how you can interrelate. Is that clear to you or not? And along with that, what you will remember? You will remember these things: relation between error function and complementary error function. Q of x plus Q of minus x is equals to 1. Q of x and complementary error function is having the relation of 1 by 2 error function, complementary error function of x by under root 2, and then this is the definition of q of q function. So this is the most important one. You need to remember the definition of q function: 1 by under root 2 pi x to infinity e to the power minus t square by 2 dot dt. Let's meet in the next lecture. In the next lecture, we are going to study about some standard random variables and their PDF. So uniform PDF we are going to see, and quotient PDF we are going to see. So let's end this lecture here. Let's meet in the next one. Thank you very much.